In a town down south where the fireflies glow, there's a man named Michael with a vision to show. Building towards the goal, he's got the spark, dreaming of a future that'll light up the dark. But on the other side, Bill Nye's on the rise with his laptop charts. He's cut down all the lies, and it just fits. It's all in the map. You can't pull from the ether, you're just chasing a path. But oh, Michael's rising like a morning sun. With the power of ether, he won't be outdone. Now stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. In the heart of a laugh, the tension was thick. Skeptics gathered round the table ready to pick. Joe shows proof, but let the case clear. And I find the stream, you're just chasing a spin. But Michael smiled live with fire in his eyes. Just watch as I spin, let the naysayers cry. You're spinning fast and a heart full of fight. I'll show you the power that's hidden inside. Oh, Michael's rising like the morning sun. With the power of ether, he won't be outdone. Well, stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. Best there's ever been. Cast away. Alienated from the aims of that inventor in disguise. Ideas ahead of time dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? On them, Kevin structures crumbling from the same old Sam. They laugh like I'm crazy, but I see it all so clear. Exploited paper under injustice burning ears. Fighting for a change in this wasteland of noise. But they call me foolish while I teach and boys. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Oh, benefactor boy, keep fighting the fights, chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? And in the depths of shadowed halls, I wandered all alone, casting whispers, binding chains, demons of my own. Toxic deafening, now spread on my frail soul. I once spin my mirror, haunted by my role. But in the echoes of my cries, just the light emerged, guiding me to where my true results are. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow, all these paths of forever defend. Shattered glass beneath my feet, scars I wear but dry. Stormy night just turned to dawn, I wear truth as my guide. Anxiety's dissolved in the sun's golden rays. See my destiny through time and space. The fears that once consumed me now they take. For in my heart a new world is proclaimed. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow, on this path of forever depend. With symmetry I found the power, blessings granted by the hour. Together we will come away. Revolution calls and I'm strong. Now I rise from the shadows with wings of fire I ascend, free from the chains of sorrow, on this path of forever depend. In the depths of his oppression, it's the rise of a true nation. In a lab, my dust cracks the code tonight. Oh yeah, that's true. Wires and circuits to shine in neon light. Oh yeah, seen you creating power from the air. These smiles and delight. Oh yeah. Mike does it right. Hey. Mike does all my keys to one, teaching us knowledge, lighting the sun. Trumpeting his legacy alive is his. Mike does knows we're his biggest friends. Down in the basement, secret starts.
What's going on, everybody? Welcome back to our Free Energy Fridays pregame show for the League of Extraordinary Inventors, which kicks off at 9 p.m. every Friday. For now, we're going to deep dive into some interesting topics, continuing on our last Beneficence TV live stream on Over Unity. So, you all know me. I'm your friendly neighborhood benefactor boy, independent researcher looking into reverse engineering the PoE vortex coils of First Stop Energy and more fringe science. So as we delve into the topic today, I invite you to open your TV guide and follow along if you can with the link in the description, and I'm about to put it in chat as well. Un momento, and I will put that up on the screen for those of you who can't pull it up. Welcome, welcome everybody. Okay. So this is our pre-game show TV guide. I invite you all to follow along in the presentation that I have for you today. We have a lot to go over. Specifically continuing on our last live stream about Beginner's Guide to Over Unity and some updates on new results that I have from my coil system. So let's just jump right into what I got lined up as soon as I bring it up on the screen. There we go. So we'll put that. Yes. Okay. So here we have today's TV guide, which is a continuation on last stream's Beginner's Guide to Over Unity. Blow that up a little bit, flip the screen here, and we can get started. All right, there we go. Can you all see that? All right, so before we jump into what I had lined up for today, I was just sent an email with some breaking news. Now, this comes straight from Congress. As you know, there have been UFO meetings, specifically with whistleblowers, talking about UFO technology, but they haven't really delved into the free energy aspect of it all. For the long time these congressional hearings have been going on, I think a couple of years now at least, until now. So this is the first time where, you know, we have a recognition of an exotic form of energy that we do not have. Oh, let me make sure. Oh. There we go. Sorry about that.
In regard to technology is a
we got to do this whole
of that and see. I think moving forward in regard to technology, Mr. Gold, if you can answer this real quickly, some of these aircraft, it seems that they are operating off of energy that we don't currently have. But just yes or no, in your opinion, if we were able to obtain that, would that impact humanity for the better or negative?
Would certainly save us some money on funding on Artemis.
Definitely.
And this is a national security issue, that if there is such technology out there, we're not the only country that might have access to it. We don't want to be on the wrong end of technological surprise.
So
All right, so I thought that was pretty interesting. They're finally talking about the free energy aspect of the whole UFO phenomenon, which is very important. Very important. These things aren't flying off of gasoline and diesel or gas. They're using 0-point energy, you know. So here we have the Beginner's Guide to Rodent Coil Over Unity and a recap of last stream. So, what exactly is over unity? Over unity refers to systems that produce more energy output than input, defying standard energy conservation principles in traditional physics. Though controversial, many claim that these setups can theoretically exceed 100% efficiency by tapping into unknown or misunderstood forms of energy, such as zero-point energy. Overunity, sometimes called free energy, is the idea that a system could produce more usable energy output than the energy input it receives. It's essential not to confuse overunity with perpetual motion machines, which are hypothetically capable of running indefinitely without any external energy source. Overunity systems are different because they don't necessarily produce endless energy, but may achieve very high efficiency exceeding 100%. For example, if I manage to double the voltage in a system while maintaining the current, I'd be achieving about or exactly 150% efficiency. This is overunity because it exceeds the input energy but falls short of a true self-sustaining loop. Again, we need 200% efficiency or more to overcome any losses of the system. And losses, I mean the system trying to, the amount of power that it has to use to power itself, it needs double, basically. Or you're not going to provide that self-sustaining loop. You're just not. You're going to fall short of it. You're going to be very, very efficient. So to fully recharge a battery powering an overunity system, you'd need closer to 200% efficiency or higher to overcome all energy losses. A system operating at 150% is still highly efficient, but it's not self-sustaining. And it's important to make the distinction between zero-point energy and perpetual motion. It's kind of like all fingers are all thumbs are fingers, but not all fingers are thumbs type of situation, right? Okay, so for phase 2 of developing the zero-point energy generator there are 3 potential routes. We have the Joule Thief circuit. We can try to demonstrate a low-power, high-efficiency system with the Joule Thief for off-the-grid applications. This type of circuit could help examine the coil's performance with induction heating and lighting. So right now, I'm going to play a video for you guys so you get an understanding of how the Joule Thief works. And this is specifically a big shout out to rimstar.org. If you see right here, go subscribe to his channel if you would like to see more videos like this.
I'm going to explain how a basic Joule Thief circuit works. Briefly, for those of you who don't know what that is, it's a circuit that allows a battery to light an LED, even if the battery doesn't have enough voltage to light that LED. For example, this LED needs 1.85 volts, but this is only a 1.5 volt battery. To see how to make this circuit, check out my video, Make a Joule Thief for Zombie Batteries. So on with how it works. Here's the circuit with its few parts. A double...
Yes, please go subscribe to rimstar.org. Okay, RIMSTARORG if you would like to see that video, because I'm not going to show it. Just show a little bit of this.
A 1.5 volt battery, a resistor, a transistor, and an LED. There's also this ferrite toroid with 2 coils of wire wrapped around it. In this case, one coil has red insulated wire and the other has green insulated wire. When it starts up, voltage from the battery is across the resistor, green wire coil, and the base and emitter of the transistor. Now, some of you may not be familiar with transistors, so let me explain them a bit. This explanation will be for an NPN type transistor. There are 2 paths that electricity can take through a transistor. One is between the base and emitter, and the other is between the collector and the emitter. But this path between the collector and emitter is closed unless there's enough voltage across the base and emitter path. Basically, the path between the base and emitter controls the path between the collector and emitter. To give an easy to remember analogy, imagine a transistor is a set of pipes shaped like a Y. 2 sections of pipes have gates on them, both of which are normally closed. The gates are also connected together, so if you open this gate, the base gate, then that automatically opens the other one too, and water can flow through both of them. If you close the base gate, then that closes both of them. Note that only the base gate has a handle, so the base gate is used to control the flow through the collector gate. Oh, and water is allowed to flow in only one direction, out the emitter. So back to the transistor. When there's enough voltage across the base and emitter wire, electricity can now take both paths, between the base and emitter and between the collector and emitter. And if you look closely at the circuit, you'll see that if electricity is flowing between the collector and emitter, that means it's also flowing through the red coil. But what about the LED? In order for the LED to light up, it needs a certain minimum voltage, 1.85 volts in this example. Since we have only a 1.5 volt battery, the LED doesn't light up. Yet. So now let's look at the two coils. You may not have noticed this in the diagram, but the two coils are connected to the circuit in such a way that they oppose each other. You can tell because the end of the red coil that's connected to the positive of the battery is here, but the end of the green coil that's also connected to the positive of the battery is over here. So for the red coil, electrical current will flow this way, and for the green coil, current will flow this way. Clearly they're opposing each other. Note that I'm talking about conventional current here, not electron current. When you run electrical current through a coil like this, that creates a magnetic field around the coil. Notice that wherever the coil is around the ferrite core, the magnetic field is entirely inside the coil. Both coils create magnetic fields, but the one created by the red coil is the strongest one.
So one key distinction here is we do not have a ferrite core. We are using an air core with the rodent coil because it doesn't have a core at the moment. I could try putting a ferrite core, and that's going to be an experiment for the future, obviously. I really want to do that. But for now, we're just using an air core. So that's a big distinction here. And as you'll see in some of my videos with the rodent coil, using a modified Joule Thief circuit like this, a very simple circuit, we can get up to 20 to 21 times voltage output. Now, we are sacrificing a lot of current, but depending on the application, that's pretty incredible, right? Because you can do a lot of LED lighting without like an inverter and the waste that an inverter uses, for instance. So you can kind of tune it and just have those basic essential components.
We'll pay attention to it only. An interesting feedback happens during the time that the red coil is creating a magnetic field. That changing magnetic field induces a voltage in the green coil. What's good is that the voltage is in the right direction to add to the voltage already being provided by the battery, and increasing its voltage also increases its current. Now remember, the green wire is the one that runs to the transistor's base and emitter. Increasing that current forces the gate open wider. That opens the gate for the collector to emitter wider, which allows more current to flow through the red wire. And remember, the red wire is also the red coil. So that increased current makes the magnetic field stronger, which results in a stronger voltage in the green wire in the direction that helps the current in the green wire, which opens the gates still wider, and so on. The end result is a feedback that causes the transistor gates to shoot fully open very fast. But still our LED isn't lit. That comes when all this falls apart, which is what happens next. At this point, one of a few different things can happen to cause this whole process to reverse. If the battery voltage is above around 0.75 volts, then the magnetic field can be built up in the ferrite core to a point where the core can't allow it to build up anymore. We say the core is saturated. At this point, there's no more changing magnetic field. And so all that nice induced voltage that was adding to the battery voltage for the green wire vanishes. And without that voltage, the gate between the base and emitter starts to close. And when it does, the gate between the collector and emitter also starts to close. And so the whole process begins to reverse. Since the doors are closing, there's no longer sufficient current to maintain the magnetic field. It collapses. And when it does, a similar feedback to the one that happened before occurs. That collapsing magnetic field is in the opposite direction of what it was before. Just as before, the changing magnetic field induces the voltage in the green wire, but this time it's in the direction that subtracts from the battery voltage. This helps to close the transistor gate between the base and the emitter, causing it to close even faster. And of course that also closes the gate between the collector and emitter. Both gates quickly slam shut. The collapsing magnetic field also drives a current through the red wire. With the gate between the collector and the emitter closed, that current takes the other path, to the LED, creating a voltage across the LED. At first it's not strong enough to turn it on, but as the magnetic field collapses really fast, there's even more current and a faster rising voltage for the LED. And so the LED quickly lights up brightly. Once the magnetic field in the core is all gone, there's no more current for the LED, and it turns off. And we wait for the battery voltage to start opening the base to emitter gate again to start the whole thing over again. And that's how a basic Joule Thief circuit works.
Alright, so again, that is rimstar.org, RIMSTARORG. And he has a lot of cool videos like that. For now, we're going to be going into the second potential route that we can take with our phase 2 testing of the rodent coil, specifically when rolling out into phase 3. So we're considering phase 3 for these tests. And when I say phase 3, I mean trying to utilize the coil to be an efficient form of transportation in some way, driving a scooter or small transport like that of some sort. So this is what our end goal is for phase 3 testing. So phase 2 is trying to get the most efficient system. We're going to try a bunch of different routes here and see which one would fit our need in that respect for phase 3. So the next option would be maybe a more practical option for this, in my opinion, which is the Bedini-type pulsed motor circuit. And we need to investigate a Bedini-type pulsed motor circuit for its pulsed resonant properties, potentially unveiling any symmetrical H-wave effects. This setup might offer insights into creating and amplifying resonance within the coil. And what I mean by this is, specifically, I found a partial or an almost complete H-wave form in the rodent coil itself when it's in resonance. So it's already producing an H-wave, and the Bedini pulsed motor, like a Bedini SG, is perfect for that. In my opinion, I think it's the perfect type of coil that we can use for that setup. So we do have, courtesy of Shanjax, a modified Bedini SG right here. I'm going to show that to you real quick. It's really cool. It's basically two Bedini SGs. You can see one on top, one on the bottom, and the batteries are replaced by capacitors. So he said it makes a really good pulsed motor system. And as you can see here, it's very cool because you can swap from AC to DC. See, this is using 2 kilohertz AC waveform, right? And we can swap it for a 4 kilohertz square waveform. So that's pretty cool. I think that's cool. But yeah, you guys, it's all in the TV guide if you want to mess with this and, tinker with it. Viewer discretion advised, though. You do this at your own risk. These coils can be dangerous and produce high voltage and a lot of ozone, as we've seen with Michael's setup. So we do not take responsibility if you hurt yourself, damage your components, or anything like that. Please make sure you're a professional or you have confidence in your skills in working with high voltage equipment. Please be safe. That's all we ask. All right, with that, we're going to move on to our third option, the amplifier board. Now, this is also showing the most promise at the moment. And specifically, when I look back at some of the old archived footage from Daniel Nunez of First Stop Energies, whose experiments and coils we're trying to reverse engineer at the moment, he specifically said to a PhD who is trying to, investigate his over unity claim, and he had all this equipment and stuff, and he was talking to him, and he's like, yeah, I never really got over unity with the Joule Thief. It was really only with the amplifier, the true AC sine wave. So that's very important to note. I think I don't think it's impossible to get it with the Joule Thief. I think it's very possible, specifically with maybe a circuit like a dual thief, like we see Gerald set up. I call it the dual thief because it's basically 2 Joule Thieves in one. And Nathan from Old Man Builds also graciously gave us his cold energy circuit, which we'll be getting into in a moment as well. So lot to go into here, and also some new results from the lab and some new videos, all right here live on Beneficence TV. And if you're not aware, we do have a goal set. So if we get 10 super chats by the end of our live stream tonight, we will put together, or I will put together a Joule Thief blindfolded. Yes, I will do the whole thing. I will, blindfold myself. I will sit folded on legs folded on the ground with the incense burning and all that. So I feel pretty confident in my ability to do that at the moment. And if you'd like to see that, that is our goal for the evening. So let's continue on with examples of over unity from Daniel himself. This one is one of my favorites. I like this one because he's actually using 2 coils sandwiched on top of the main coil that he's using as his connection. And I don't think the top and the bottom coil are hooked up. I think they're just used to sandwich in that magnetic field and compress it, I guess, maybe more uniformly. Let's check it out. Let's see what he has to say about it.
How's it, my bro?
Brother Charles.
Whoa.
You see what's going on live?
Yes.
I'm in competition with Mike Tyson.
What are you doing?
We just extended the range.
Oh my gosh.
We've got 576 LEDs, and we're only using 1 watt.
Oh my god.
Yeah, and the plot thickens.
You can't see the other
How much
panel on the
thicker can it
side.
get?
It's like covered by
Yeah.
his.
So I did the math. I did the math on these two. So to light up this number of LEDs, you normally use 28 watts, and we're using 1. And the battery would normally last 58 hours. Or excuse me, it would normally last 1.5, and it's lasting 58 hours with this system.
What?
That's incredible.
58 hours. So we increased the runtime by putting on more LEDs. Yeah, man.
So is all you need is a big capacitor, and then in theory you can charge another battery in less than 58 hours.
Exactly, yeah.
Really?
Yeah. What's up, Gerald? Hi, Mike.
How long does it
Hi,
take
Nathan.
to charge one of those batteries?
Glad to have you guys here on the pregame show.
Look what Daniel's done. Can you show us all the lights that you've got in series?
That's 576.
Can you show us in the camera?
Is it? Hold on a second. Is it?
Oh wait, no, those are the lights on the left. Okay.
Yeah. I'm not seeing my camera.
Okay, but no, I see some lights on the left and some lights on the right. So look, he's
There we
lighting
go.
all of these lights with 1 watt of power. Oh. Oh
Camera's
my God.
very, very low res, so
Oh my
it's
God.
very hard to make out some of the details of this
Oh my
video. I
God.
might have to go back and
So basically,
Upscale
what
it.
we've done here is we took these 2 coils there, and these coils are acting like pickup coils to condense the field and turn on this other panel there.
Okay. Oh my God, man. That's really powerful.
Yeah,
Okay.
it's
So 1 watt of power is like you can,
Like the whole house.
you know, you can just like, you wouldn't even notice it electrocuting you, would you?
what was that?
You wouldn't notice 1 watt electrocuting you, would it?
I wouldn't say that. I wouldn't say that we have 1 watt of power going through the lights. So you'll feel a bite if you put your finger on it. It's not going to really zap you till you're dead like the regular wall current would.
No.
It would be a little shock, but
But you said it's just 1 watt that's going into this, right?
yeah, but the output potential is clearly more than 1 watt.
Oh yeah. We should try the electrocution test.
It's charging. What is this?
You should probably do it like a.
So is this the resonance here? That you're trying to get it in resonance so that it...
Well, that's because I have a potentiometer on it.
So it will sometimes click out.
Well, depending on the value, it's all about sound frequency. So whatever sound frequency you put into it, you get a different effect. So it's a matter of tuning it into resonance. You find what the maximum output frequency is, and you try to dial into it.
Now this is what Franklin does with the Utron, but it takes him ages to tune it up. Like really fine tuning to find exactly.
No, see, right after here, what just happened there, what we would do is we read the potentiometer where it's at now, the value of it, and then we replace the potentiometer with the set value resistor. That way I can always turn it on to be this same exact sound frequency. You see, so in the long run, to make more stable units that don't really have so much dialing.
Right there, it sounds like he is using the Joule Thief for this setup.
Can I add my friend Dave to this conversation, who's helped us get in touch with this facility in the UK, this big manor house?
Sure.
Okay, cool. Dave? Oh, he hasn't answered. He's like looking after vulnerable kids and these programs. Hi, Dave, are you there? Oh, it's just ringing.
Is she doing her homework over there?
Yeah.
I'm copying what my dad wrote. But I wrote, where did it go? But I wrote these ones.
Yeah. My friend Daniel, can you see those stack of coils over there?
Hello, Dave.
Hello, mate. You good?
Doing well, doing well.
Good, good.
Can you see in the video feed?
No, I'm on an iPhone, so I've just got voice.
Oh, okay, that's a shame because Daniel's got 3 Rodin coils, Abha coils, Nunez coils, unification coils, and they are they're lighting 500 and something LEDs with 1 watt of power.
Wow.
576.
Fantastic.
Yeah, totally cool. So, yeah, I thought I'd introduce you before the call, which, whoa, it's going to be right now. Hey, guys, I better get off and start making this call.
Okay.
So I thought that was pretty interesting. That's something we're going to have to try, obviously, when we have another couple of coils the exact same size as our Mark I, which I am printing off another one for a friend, and then I'll be printing off another couple, one for me and one for maybe Nathan as well. So we're going to be making more Mark Is. They do seem to be getting some pretty interesting results. But again, I don't think it's the only coil that's able to get over Unity. So we'll get into some of that in a little bit. All right, so as you can see, the Jewel Thief option is very simple. This is Michael Morell's modified Abha excitation circuit. So this is his take on the excitation circuit that Daniel Nunez came up with. So basically, it's pretty much the same. Only I think he switched the start of the channel's connections. So I think it used to be the opposite connection, and Daniel had a different potentiometer. It was 100, I think it was 100K ohm potentiometer, and there was no resistor, 1K resistor here. So it's slightly different. He was using a different transistor as well. So those are all variables to keep in mind if you're messing with different transistors. Supercap Jewel Thief, we're not going to watch that, but that is something that is a cool video if you're interested. I forget, it's one of the big YouTube streamers. But yeah, that's a cool video. For now, we're going to move on to the Dual Thief. Now, this is what I call Gerald's Jewel Thief circuit. Specifically because it appears he uses 2 transistors at least. I'm not sure if this is the actual... Yeah, this is a stereo circuit. I think I put the wrong one up here. But he has a circuit. I don't know if he actually released the diagram for that one yet. Let's see. Hold on. Give me 1 second. Let me scrub through this. Yeah, I think this is a stereo board. So this is just one transistor on the circuit. So there is another circuit that I don't know if he released it yet, but he will soon if he hasn't, where there's 2 transistors. And I call it the Dual Thief because it's basically like oscillating, I believe what he said, back and forth between the 2 transistors using kind of like a dual mirror setup, somewhat similar to what we see in the Bedini modified circuit that we saw earlier from Shanjax. Shout out to Shanjax. Really cool circuit there. So yeah, we'll skip that for now. I apologize. I think that is definitely the wrong circuit. So moving on to Nathan's cold energy circuit. Now this one's interesting, and this one's something that I really want to try, but there is a question that I have, and specifically it's, am I only using 1 channel, or where's the second channel going to be introduced into the circuit? So that's the only question I have, because I have 4 outputs on the coil, and I'm wondering if I group them in a specific way or what Nathan recommends, but let's just take a look at a little bit of the video. This is Nathan's circuit from Old Man Builds. So if you're not a subscriber to Nathan's channel, Old Man Builds, I highly suggest that you subscribe. Go over there now, subscribe, and you'll have some awesome access to amazing information regarding fringe technology, like this cold energy circuit, which he basically designed for our coils to utilize the back EMF and cold energy more efficiently. And I'm really excited to try it out. I have a couple questions. I gotta, we gotta talk through, and he's gotta, maybe help me out with the circuit a little bit. So with that said, this is gonna be one that is definitely high on our list when we have the ability to get, a 12-volt battery, and I do have a bunch of capacitors we might be able to make a cap bank with. So we'll talk to Nathan about all that, materials list and everything, future stuff. So we'll have all that open source in the future when I do testing on this circuit. We also have a resonant buck converter. Now this is another option.
Attention retiree.
So if you were not tuned in last time I went live, we were checking out Mr. Warren's channel. And I really suggest you subscribe to his channel, especially if you're interested in trying to replicate some of these coil experiments, because he actually did. He apparently replicated successfully a lot of Daniel Nunez's experiments, along with introducing his own circuits and all that stuff. So this is one of his circuits. It's a resonant buck converter radiant circuit, and he's using his PoE coil with it. So I just want to take a look at that real quick.
All right, so I've been working on my circuit, and we look back to Tesla's schematics, and he talks about this circuit. Here we have a charged capacitor with a break going directly into the primary, and this is a lot like a regular pulsing circuit with a MOSFET here and a charged capacitor or battery. This here is basically to get high voltage into the capacitor. So we can just look at this as a battery, essentially. So we have a battery, brake device, and our circuit, our coil. And
so I gotta turn that down a little bit. There's a little bit of background noise. It might be music. So we're gonna turn it down a little bit and turn the subtitles on.
So it doesn't work very well, which is true. So then he goes on to say that you should have the brake here instead and have these capacitors to prolong the oscillations. And this is his final one.
And let us change the playback speed.
You basically balance this capacitor takes up all the energy of the transformer. So this capacitor will take up all the energy of a coil that's pulsed. So this is our pulse of the coil, and then it's like a resonant this is like a buck converter right here. If we pulse this coil with the brake, we're going to get a charge into here as this collapses, right? So the idea is to get this coil and this capacitor in resonance so that the reactances are equal. And when that happens with this inductance added, basically current's going to go through this system really easily. Now, if the frequency of this system is the same frequency of this coil, then we get resonance here and here. So he added this to balance this capacitor a little bit more. And so this is the circuit I came up with. Is we have a battery, we pulse a bifilar coil. If we don't have a bifilar coil, it's going to be a lot harder to tune. So we pulse this coil with the oscillator, and then the energy that, the momentum that's stored in the magnetic field will go into this capacitor, and we get current flowing in here. Now the goal is to have this and that, these two reactances, the capacitor and the inductor, at the resonance of this. So originally I used this type of inductor, which is not bifilar, and it was really hard to...
See what he said there? We need to get the capacitor and inductor in resonance. We're not doing that in our system, I don't think, because we are seeing some interesting gains. We can't confirm anything at this point because the results are a little mixed, specifically because my multimeters are not picking up the same thing as my oscilloscope, and I think I need more sensitive equipment. But suffice it to say, we are observing with the oscilloscope some interesting gains with the system currently. Supposedly, it is not translating as well as it should because the load is not in resonance with the capacitor. So the load also needs to be in resonance too, because it's all one thing, the inductor.
So it's cool because now at resonance, we're only pulsing this bifilar coil, and all the energy, the high frequency radiant, is it's actually being given a path to travel now that's not wasting energy. Before, I had this as my primary, and then, you know, we drain energy to ground. So now we're draining the energy through my coil to ground. So it's way more efficient. I never pull over a whole amp now because this coil has a pretty high resistance because it's small wire, but it's got a high inductance. So it's got a nice back EMF spike, and then I got microcapacitors as
see, it's got a lot of inductance. So it's in resonance with his system.
This capacitor here. So at resonance, it works really well. And yeah, we can play with the frequencies.
And you hear that hum. That's what we're looking for, and we found that hum. So we know it's in resonance. We know it's in resonance. We just need to know how to manipulate the energy a little bit better. And as you'll see in a minute in some of my videos, we are getting some interesting gains apparently, but specifically I think we have to increase our load. And I don't have like a 10 to 40 watt LED panel or fluorescent tube or whatever that I can put on top of the load that I have right now or whatever. So until we can get our load in resonance as well, I don't think we're going to see all the gains that we can potentially see. So that is the problem that we're facing at the moment. So you'll see here, I'm specifically using now, I've gone back to the stereo amp receiver. I'm using the mini board, the Drax. So this mini board can only put out 80 watts, 40 per channel, okay? And it's interesting because you'll see in a minute some really, really interesting effects of this system that kind of hint that it's getting extraordinary gains, but it's just not translating into the load I have. So we'll get into that in a minute. But for now, I want you guys to be familiar with the Nunez method. The Nunez method is specifically this method on the right. This is the open circuit method of resonating the load with the capacitor and the conductor of the coil. So you're resonating the coil, the capacitor, and the load all together, along with, I believe, I haven't heard anything from the stereo amp board itself. I haven't heard it humming, but, I can imagine that's, the energy's going back and making a loop, so it's got to be in resonance as well. So, and there are limitations to these stereo amp receivers, specifically distortions past 20 kilohertz on a lot of them. You really need we need a guitar amp. I do have the stereo amp out, so we can try that tonight on the League while I tinker in the background. We'll compare results between the mini board and the proper stereo, the full board. But for now, I want you guys to get familiar with these two circuits. Now, before, we were kind of using a hybrid of these two. We were using the open circuit method, but also connecting channel A and channel B, right? So specifically the start of channel A to end of channel B. So that's where we were at before. With the results I'm about to show you, we do not have that connected, right? We're using straight up the Nunez method with just the 0.15 unifarad capacitor, but we do not have the 10 to 40 watt load, okay? This fluorescent tube is, I think, what we need to demonstrate this effect, because we need the load to be in resonance with everything else, and it's just not. Ladies and gentlemen, I just don't have the equipment to produce that kind of effect at this moment, but soon we will. So for now, I just want you guys to get an understanding of how this works. Now, we have a frequency generator, right? And the frequency generator can be anything from an app on your laptop or your phone, or a proper function generator that you have in your lab, right? And the frequency range that Daniel specifically recommends is 12 hertz. Ooh, that's something I didn't pick up on. Oh, boy. Oh, I missed that. See, you don't pay attention close enough and you miss these details. I thought it was 12 kilohertz to 18 kilohertz. It's 12 hertz to 18 kilohertz. Okay, so that changes everything. So that actually, going back and looking back, we're doing good with our frequency ranges that we're experimenting with now. Okay. Woo! Wow. Okay, so going back to the frequency generator and the order of the circuit, you have the frequency generator, and you're putting 12 hertz to 18 kilohertz, whatever your resonance range is for the coil that you're working with. Okay? And there are ways to tune it, and I've shown you and I've demonstrated in other videos how specifically, and we'll get into that in a little bit. But I want you guys to get an idea of how this circuit works. So you have the frequency generator hooked up to the stereo amp receiver, the input, right? So just as you would plug in your TV or whatever, you have the frequency generator plugged in, and you're putting, your, let's say, 5,000 hertz into the amplifier, okay? And you have one channel coming out. You have a left and a right on that channel, and the left is going to channel A, and the right is going to channel B, okay? And between the load, you have, in parallel with the load, you have your capacitor. Now, be aware, this method may create ozone, which Michael Morell did experience, and he did have to clear out his apartment for, which I have to say is very, very dangerous. Please be careful when you're experimenting with this. It does have the ability to produce amazing amounts of ozone. You would be amazed at such low power inputs. So please be sure to test in a well-ventilated space. Now, what it specifically says here is, here are some wiring diagrams for powering vortex coils. On a closed circuit, the coils can be used as speakers by putting a magnet in the center. Also great for demonstrating monopole properties. By opening the circuit and connecting lights such as LEDs, neon bulbs, fluorescent tubes, and xenon bulbs, the coils are able to draw in more resonance and create high voltage. All right. So that's basically how this open circuit works. Okay? You're not just creating resonance within the coil. You're resonating the whole system together. It's one system, right? And that's how you're minimizing any losses and actually increasing some of the output. You're getting gains here. And it does say using a sound source that allows for precise tuning. 1 hertz increments is ideal here. So that's what we're going to do from now on. And I have been doing small increments, but not 1 hertz, maybe like 10 hertz. I've been, incrementing it, but that's what we're going to have to do. We're going to have to tune it. When we find our proper load, that is, we have to find a proper load that resonates properly with the circuit first, and then we can kind of tune the system in 1 hertz increments around the area that we see that wireless induction happening in the hum. Those are indicators of the resonance area that we're finely tuned in. So the coil will literally sing to you. All right, so the update. After many, many failures, we finally have some positive results with the Nunez method. Let me emphasize here that this is without using Michael's modified bridge connection, where we use the open circuit shown above, but also connect A start to B end, resulting in a hybrid between these two circuits. These new results were obtained from just the open circuit method, no bridge between the channels except for the load. So the way I have the multimeters hooked up, and you'll see in the graph below, because I want you guys to get an idea of how I'm measuring this and the proper way to measure it, and don't make the same mistake that I did. Okay, so multimeter A, positive connection, is connected directly to the positive stereo amp board output. The negative is connected to the channel A start. Channel A end is connected to the positive terminal of the load. Okay, so you can see that down here. All right, we're in series with between channel A and the stereo amp. Okay, so you have the positive of the multimeter hooked up to the positive of the stereo amp out, and the negative hooked up to the start of channel A, effectively putting this in series, allowing the current to flow through and be measured. So this is how I'm measuring the current on the input. All right, so channel B end is connected to the negative end of the stereo amp board. So you can see the end of channel B here is actually connected all the way up here to the negative output of the stereo board. Right? So that's very interesting, and that's worth noting here, because it's very easy to get, it's very confusing sometimes when you're first looking at these diagrams. I know from experience. I confuse myself on a daily. So going back to how we have this measured, we have channel B end is connected to the negative end of the stereo output. And in parallel with the load is a 0.15 unifarad 2000 HV Tesla cap. Okay? So multimeter B, which is measuring the output current, is connected between channel A, positive output, and the positive rail for the load. Okay? So here's multimeter B measuring the output current. So it's literally between the capacitor and the positive rail of the load. All right, and that's how we're measuring the current. And I don't actually have it described up here in this little description, but the voltage, this is how we're measuring the voltage. So this is multimeter C and multimeter D. So multimeter C here, you can see it's basically hooked up positive to the positive output of the stereo amp, negative to the negative output, right? And then the multimeter D, which is measuring the output voltage, is basically hooked right up to the capacitor. All right. So, the results. These voltage measurements were taken from the capacitor without the load connected. And I have a suspicion it's because this load that we have is not resonating properly. Taking it off, we get the actual potential of what's coming out of the capacitor, whereas putting it on, we're just basically getting an impedance mismatch. So you can think of it as a giant pipe coming out of the capacitor, and this pipe is draining into a very, very small pipe, which is the load. So it's trying to squeeze a lot of energy into a tiny, tiny pipe. That's my theory, at least. So it must be emphasized that these have not been verified yet, and until they are subject to scrutiny. All right, let's dive into it. So right now, you can ignore these first two efficiency results because they're specifically making assumptions. So we're making assumptions that the current is being maintained in this column, and I haven't measured the current in this specific bridge connection. Remember, we're measuring this. These new results are the no bridge connection, just a straight up Nunez method without connecting the two channels together directly. We're just connecting the two channels through the load. So you can basically just take this at face value. It's assuming that the same current is being maintained, but it could change. So with no bridge, the voltage seems to be 2.93 volts on the input and 2.93 volts on the output. And this is measuring with the multimeter, by the way. This is not the oscilloscope, which the oscilloscope, I get way higher readings, okay? And we'll get into that in a minute in the videos, okay? But this is just the raw data here from my multimeter. And the output voltage, we get 2.94, so a slight increase. And again, this is at 50/50 frequency. I don't have it up here, but actually let me write that in here. The frequency is a sine wave at 5050 hertz. So sine 5050 hertz. All right, so we get a slightly higher output voltage without the load and no bridge connection. All right, so that translates into, with these current readings I'm about to read, into about 100.34% efficiency. Okay. I'm sorry, I think that's assumed as well. Yeah, I think that's wrong. Anyways, the real efficiency data is down here. This needs to be replaced. So the current that we were reading from the no bridged connection, okay, was 24 milliamps on the input, and then 28 milliamps on the output. So it reaches 28 milliamps at max volume, falling below this before threshold. So that means there's a threshold effect going on here, where you increase the volume knob on the stereo amp board, increasing the power input to the system. And as you increase the power input until you get to 24 milliamps output from the stereo, you see losses on the current on the output side. So say you're at half volume level, it's going to read like 16 milliamps input and then 10 milliamps output, right? It's going to read as a loss. But once you reach 24 milliamps in the system, the input stabilizes and it locks in, and you're continuing to turn that knob and increase, and the output of the current just keeps on going up. So this is very, very interesting, and this is some of the most promising evidence that I have seen yet. Now, we'll get into some of the videos on that, which are very fun. Some very fun stuff. So if we can calculate the power wattage for the no bridge connection, on the input we have approximately 0.07 watts, and on the output we have approximately 0.08 watts. So this translates into about 117% efficiency. Output power is slightly higher without load connected and no bridge between the two channels. So this is all without factoring in the power supply power up. So this is not actually over unity by any means. As you'll see here in a second, excuse me. But yeah, we have a lot more testing to do. This is the COP and efficiency calculations and how I got to them using ChatGPT's help here. So again, if I have any math calculation errors, please let me know and excuse them. This is all preliminary. We're just trying to get an idea of a baseline for this coil to see if we can see anything extra coming out with the rudimentary equipment that I have available. And we're going to try a couple of tricks specifically with the capacitor, and this is the interesting thing that I was kind of hinting at earlier. And you'll see in the video, I don't want to spoil anything, but it's very significant. It's another huge red flag that we're getting a lot more energy out than we can actually see at the moment because of the load is not efficiently resonating with everything else in the system. Now, what we can note so far, there does seem to be a power threshold observation. Well, now what this means is the output current exceeds the input current only when the stereo amp is putting out at least 24 milliamps into the coil. Below this power level, the output current drops, suggesting a threshold effect where efficiency and output power are maximized only at higher input levels. Now, this again is probably based on the load that you have. So it's all relevant, right, to your system. You want to take everything into consideration when maximizing the efficiency of these systems. As we increase the volume on the stereo, we see the input current stabilize at exactly 24 milliamps, while the output continues to increase beyond it. While at the same time, we are maintaining the voltage or even increasing it as indicated by the 50-volt capacitor blowing up. Ooh, which doesn't happen unless the capacitor hits 50 volts or more, indicating an underestimate in voltage output. All right? So this is very significant. And we're going to watch this video in a second and watch me scream with excitement and terror, because it's terrifying when they blow up. But over unity effect noted. With a COP of 1.1, if we can assume that everything is accurate, and I don't think it is. I think we're getting a lot more voltage. But if we can assume everything is accurate at this point, we're seeing at least 117.1% efficiency in the system at 50-50 hertz. 50-50, ladies and gentlemen. Pretty cool number. That might just be a luck of the draw with our coil, because, you know, the length is really dependent on that number. But this is all provided that the power level is at or above 24 milliamp threshold. All right. And the other thing we have definitely noted is we know there is something wrong with our voltage readings. While our oscilloscope indicates approximately 14 volts input to the coil and 25 volts output, which does kind of make sense. It does have that capacity, right? We did blow a 50 volt capacitor, 10 unifarad, which indicates at least 50 usable volts were going into the load. The number in the charts are taken directly from my multimeter with true RMS, which averages out the peaks. So this could be another issue, right? And this is why we need a more advanced oscilloscope. Don't be mistaken, though. This is not an example of practical over unity. If these numbers pan out, they would simply represent a proof of concept, demonstrating it's possible to step up voltage or current without sacrificing one or the other. The caveat here is that my stereo amp board is being powered by a workbench power supply that's putting out 17.9 volts and 260 milliamps just to power the mini board. So when you factor this in, the real efficiency is very, very low. The board runs from 12 volts to 18 volts. We might be able to turn this down to get the board to run at its very lowest voltage, but those tests will be conducted in the near future. I haven't done them yet. Right now, we're just doing the stable 17.9. Okay? So with this factored in, we are at a 1.77% efficiency, and it is a total failure for over unity. However, by replacing the board with a low power circuit, we should be able to bring that efficiency rating back up to nearly 117%. Theoretically speaking, of course. So, with this new exciting news, it is time for me to finally reintroduce the benefactor bridge so we can finally have a clear reference circuit. So I have to redesign this. Okay, if these readings are accurate, we should be able to see these numbers translate into a visual difference between the output without the coil on the right channel of the board and the output with the coil on the left channel of the board. Unfortunately, we need to redesign the benefactor bridge in order to match the impedance of the load to our coil first. This impedance mismatch is why I believe we aren't seeing the power draw we should be seeing. If this is true, essentially what's happening now is the capacitor output is acting like a giant pipe draining into the load, only the load's pipe that energy is draining into is significantly smaller, leading to a visual reduction in power output compared to the load connected to just a stereo amp without the coil, which does seem to be, powering it a little bit more, which is it's baffling, but it makes sense when you think about it. Without the coil, there is no impedance mismatch. So, or if there is, it's insignificant when compared to the coil's mismatch. So, it's going to appear to run much smoother until we find that specific matching load. This leads me to believe that adjusting the load by adding more demanding lighting, like it suggested, 10 to 40 watts, we can get more energy out of that capacitor and see the real effects of this coil. All right. So that's all for my presentation. I'm going to show you the videos now, and then we're going to go to a break, about a 30-minute break before we get into the League of Extraordinary Inventors at 9 p.m. Eastern Standard Time. So that happens at 9. You don't have to go anywhere. Just sit tight. After the break, it'll pop on. So let me load up the videos for you guys and catch up on chat. I'm really excited about all this. This is really good news. Ladies and gentlemen, I screwed up, but this is very good news. We finally have some positive results, and we finally have a direction that we can take this. Oh, Gerald says, good work, Ben. Thank you, Gerald. I appreciate that. I appreciate that. Absolutely. Yes, in 30 minutes. Nice. So Gerald has a coil theory premiering soon. Okay, cool. Everybody who wants to check that out, that is linked in the chat. Yes, that is really, really cool. He sent us part 1. I've seen it. It's very, I really suggest you go check it out. It's a really important insight into his work and in coils in general, and how to kind of maximize efficiency by ignoring the ignorance of traditional electrodynamic theory. So, Momo Cow Plus, hi Ben, where do you connect your frequency generator to Michael's ABHA circuit? Okay, so the ABHA circuit doesn't require a frequency generator. It oscillates. It's an oscillating circuit itself. So that's the thing. There's 2 different waveforms we're producing here. So with the stereo amp board, we're producing the true AC sine wave. But with the Joule Thief, with Michael's modified, we're only producing a pulsed wave, right? We're not producing true AC. So basically, what you want to do is hook one channel up to the base and the other channel up to the collector, and then the emitter and the collector are connected to the load. It's kind of really, really freaking simple, but there's a little bit more to it than that. I really suggest checking out. We have a video. Michael Morell put together a tutorial video, and I have it on my channel. Yes, I'm gonna give you the link to that video in a second. Give me 1 second. Oh, you're welcome. Here you go. So this is the tutorial video. If you have any questions, feel free to reach out to me. beneficencetv@gmail.com, or you can leave a comment, or, I do have a Patreon as well. That's easy to get a hold of me on there. We have a whole chat, and a whole host of content for behind the scenes material and early updates on some of this stuff. So with that said, we're going to load up these videos. This multimeter is connected in series to the coil output. Okay? And then the other end is right here. So you have the power rail right there. Okay? Oh. Shame on you. So as it stands right now, we'll run the numbers. If we're measuring this correctly, we are seeing extra energy coming out of the system. And this is without channel A hooked up to channel B. Okay, before we were only able to see any gains with channel A connected to channel B, like we see in the closed circuit method, not in this diagram here. That was Michael's modification. That's how we got ozone, he said. I couldn't get ozone like that. I got that small light on the top that you see hanging down, that's not
conclusive.
Connected to anything. That's in the second coil, just
I went back to the basics.
wireless induction.
Stuck with this diagram only. I'm using
an indicator
just
of
those
resonance.
components.
You can
and
kind of
just
hear it
that
humming sometimes in the
configuration.
background too.
Although the frequency might need to be adjusted specifically because we don't have Daniel's coil frame. We're using a different coil frame with a different size and different ratio. So that might be the variable we're looking at here for frequency, because that's not the range we need to be in. So maybe we have to adjust the size of this coil to match this frequency range right here. Okay?
I
And once
even
we
wrote
do
it
that,
down and
hopefully,
didn't notice.
we'll be able to see a lot more amplification. Maybe we're just not seeing enough voltage multiplication while increasing the current slightly. Maybe we're just not seeing enough voltage multiplication to hook up the load and see the gains at the same time. It's using too much of it. You know what? As I think about it, let's disconnect this real quick.
Oh boy, here we go. That's a 50 volt capacitor right
fan.
there.
Okay. Oh yeah. So look, I disconnected the fan and the output amperage went down.
What?
It went up when I connected the fan. So connecting this fan increases the amperage slightly. So it is based on the freaking load. Holy crap. Okay. So we need to disconnect this and we need to measure the voltage real quick while the load is connected. So we'll take this probe here. Connect it right there. Alright, so we didn't adjust the resolution, still 20. Yeah, it's clearly higher with the lights on. So we were at 14 before, now we're just at 15. Just at 15 on the output. So remember before. Woo!
Dude, that scared the crap out of me. But that's a 50 volt capacitor. That's not gonna, from what I'm told, that's not gonna blow below 50 volts. If it's getting 25 volts, it shouldn't blow, right? So that should be really significant. If that's true, that's really, really significant, because that means we're getting at least 50 volts of usable energy out, and we're just not seeing it translate into the load because the load's not resonating with the rest of the system. That is so cool. Okay, we got 4 parts to this video here.
Alright, so here's what just happened. We had a 50 volt 10 unifarad capacitor hooked up to this rectifier for the DC fan, so it was smooth, right? So that blew. We were only reading about 25 volts on the output and about 14 volts on the input. Now this thing, I don't think is capable of even putting out 50 volts.
It's not. It's only capable of putting out 40 watts per channel. So 50 volts is kind of pushing it, in my opinion, for one channel.
This 50 volt capacitor blew.
I think like the
So that
limit
means
for
it
these
was
things
getting
is like
at least
30 or
50
40 volts.
Or more,
Stereo amp,
I believe. So I hooked up 2 in series because I don't have a 100 volt. I hooked up 2 50 volt 10 unifarad capacitors. I should have hooked up 5 unifarad, but I don't have that specific capacitor. But it seems to work fine now, all the way. So this is when I turn the gain all the way up. 50 volt capacitor blew. So now, see, this is the input current on the bottom,
and you'll see the input to the coil, the current input to the coil, and the current output of the coil, the current that's going into the load. So input to system, input to coil, output to load. Now we're going to increase this. We're at 50 hertz sine waveform, and we push this all the way to the right because we're only using the right. You'll notice a slight humming too as we increase. Okay, so as you'll see before, the same thing happens. This gets stuck at 24 milliamps. We're all the way up in the gain now. This isn't gonna pop because we've got more capacitance. This is 28 milliamps on the output, dude.
It disconnected the fans. It works fine.
And this popped a 50 volt capacitor that had to have been getting 50 volts. This is not outputting 50 volts, although we need to confirm that. And this is only putting out 270 milliamps. So a lot of that's being wasted, or that's putting out 270 milliamps. That's being wasted in the system right here. So that's where we're at right now. It's interesting because this popped when I disconnected the load. So I'm going to turn that all the way up again.
When I disconnected it, it popped in less than a minute.
Okay, we put it all the way up. It didn't pop. Not sure what all this means. So we blew an LED. I know we blew a capacitor. Look at that. Okay, so now we have two fans, exact same fans hooked up. I'm going to turn it all the way up. You'll see we're 28 milliamps output to 24 milliamps input. Fans are spinning quite nicely. I'm going to disconnect one fan and see what happens. Okay, so disconnecting one fan though does not mess with the output amperage at all. Back on there. Just adjust the frequency a little bit and see what happens. Oh, wow. Look at that. $49 milliamps to 64 milliamps. Okay, so now here's our baseline, okay? We're at 60 hertz. 60 hertz sine wave, AC. And look at that. It's maintaining the current. 119, 120. Just that 60 hertz coming out of the wall. Something very, very extraordinary there. Now, as we increase this, you'll see that the amperage on the output side starts to get wider when compared to the input. We're at 54 milliamps input, 56 milliamps output, 2000 hertz. Let's go up to 3000. 37 milliamps input, 39 milliamps output. All right. So now we're at 4000, and you can see we're at another range where it's not really producing that effect. 23 milliamps input, 22 milliamps output. Okay, we don't, the fans kind of stop, but we can probably fix it by adjusting the gain. So let's go up to 5000, and you'll see that that fixes itself. Okay. So we're still 10 input to 9 output. Let's go to 550 and increase the gain a little bit. Okay. So as you see, as we put in more power into the system, the amperage on the output side seems to catch up after about 24 milliamps. So we're increasing the gain at 24. So it's starting to catch up. We're still at 24 on the input, increasing the gain. (28 milliamps output to 24 milliamps input). And remember, this is the same exact setting that blew that 50 volt capacitor.
So if you want my rough conservative estimates here of what's going on here, I think there's about 30 to 40 volts coming out of the stereo amp, and I think there's at least 50 volts coming out of the coil, while it's stepping up the amperage slightly based on the load. That's my opinion of what's going on here. We still need to confirm these results, but it's very promising. I am very excited. We have a whole show going on for you guys tonight at 9 p.m. Eastern Standard Time in just 30 minutes. So sit tight and stay tuned for the League of Extraordinary Inventors on in 30 minutes. We're going to go to a 30-minute intermission, and I'll see you in about 31 minutes.
Ain't alive. Mike does cracks the code tonight. Oh yeah, that's true. Wires and circuits to shine in neon lights. Oh yeah, seen you creating power from the air. These smiles and delights. Oh yeah. Mike does it right. Hey. Mike does all Mike, he's the one teaching us knowledge, lighting the sun, trumpeting his legacy alive. Is his. Mike does knows we're his biggest fans. Down in the basement, secrets start to glow. Oh yeah. With Nathan Lulu in the show. Oh, brilliant team. Mike came on Faraday. We're letting knowledge flow. Oh yeah. Energy streams. Mike does all Mike, he's the one teaching us knowledge, lighting the sun, trumpeting his legacy alive. Is his. Mike does knows we're his biggest fans. Years of thought, bringing dreams to life, turning theories into electric light. Mike and us, a journey to ignite. We've reached new heights. Hey. Mike does all Mike, he's the one teaching us knowledge, lighting the sun, trumpeting his legacy alive. Is his. Mike does knows we're his biggest fans. majestic moments in cosmic flight. Holding on to the stars of starlight. There's a light within the dark waves, guided by echoes of ancient ways. You will find our reflection. With everything there's a connection. Feel the positive sensation. Everyone feels the goodness of invitation. There's a light within the dark ways, guided by echoes of ancient ways. You will find our reflection. With everything there's a connection. Feel the positive sensation.
In base lab alone with my mind. Stable theories, they all refuse to find. I've been working on energy for a brand new day. But even in the crowd, I'm still a castaway. Alienated from the A's of that inventor in disguise. Ideas ahead of time, dismissed with narrow eyes. Benefactor boy, dreaming about the world you can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Talking love 0 point, the points lost on them. Chemical structures crumbling from the same old stem. They laugh like I'm crazy, but I see it all so clear. Exploited labor, unheard injustice, burning ears. Fighting for a change in this wasteland of noise. But they call me foolish, why teach and boys? Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice? Chasing revolutions in the darkest nights. A dreamer with vision beneath the laughter and noise. A future so bright waiting for the right choice. Benefactor boy, dreaming about the world he can't deploy. Changing the system, but treated like a toy. Ideas misunderstood, but brilliance is his boy. Benefactor boy, can't you hear his voice?
Oh boy, here we go again. The benefactor's at it with his latest theory. Apparently, the only reason free energy devices are suppressed is because of some Marxian economic conspiracy. I mean, if Ron's pants can have cosmic adventures, maybe they're the ones pulling the strings behind this too.
If my pants are orchestrating economic conspiracies, then I suppose they deserve a raise. But let's not forget, the only thing more elusive than free energy is my wardrobe. Maybe we should focus on finding my pants before unraveling Marx's mysteries.
Perhaps your pants have transcended the material realm, seeking enlightenment in the quantum coffee dimension. But hey, if they can solve the mystery of free energy, maybe they'll come back with a Nobel Prize and a matching belt. Until then, let's just hope they don't start a revolution without us.
If Ron's pants are leading the charge for free energy, maybe we should start a fashion line called Revolutionary Trousers. Imagine the headlines, "Pants that power the world." But let's be honest, if they do come back, they'll probably just demand a seat on the board.
If my pants are negotiating board seats, they might just be the most ambitious garment in history. But let's not get ahead of ourselves. First, they need to find their way back from the quantum coffee dimension. Until then, I'm stuck with the mystery of missing trousers and suppressed energy.
Maybe your pants are sipping quantum coffee with Marx himself, plotting the ultimate fashion revolution. But hey, if they can crack the code of free energy, they might just return with a business plan and a latte. Until then, let's keep our eyes peeled for any cosmic clothing sightings.
If my pants are hobnobbing with Marx over quantum coffee, they might just come back with a manifesto and a caffeine addiction. But until they do, I'll be here, pantsless and pondering the mysteries of suppressed energy. Let's just hope they don't start a trend of intergalactic fashion statements.
If your pants trend, we might see a galaxy-wide fashion revolution with cosmic catwalks. Maybe they'll even discover interstellar free energy. Let's just hope they don't demand royalties for every pair sold.
If my pants start demanding royalties, they might just out-earn my entire hedge fund career. But hey, if they crack interstellar free energy, I might finally afford a new pair. Until then, I'll keep an eye on the cosmic catwalks for any signs of my elusive trousers.
As we conclude this cosmic comedy of pants and power, remember, if Ron's trousers can navigate the quantum coffee dimension with Marx, maybe free energy's possible. Until they return, keep eyes on stars and feet in zero-gravity saunas. Tune in next time for Ethan's Doubts versus Ron's Pants. Join us next time on Nathan's Fringe Science, where we trade Newton's apple for Ron's runaway trousers, in our quest for cosmic convenience and pant-powered possibilities.
Success doesn't come from
Gerald opened a sketchy email, and now Victor's laptop full of 300 Fringe Science tabs is hacked by someone with terrible pizza taste. Luckily, their outdated science knowledge is as stale as week-old pizza, so we've got the cosmic upper hand in this pizza negotiation.
Well, if the hackers' knowledge is as outdated as their pizza preference, maybe we can distract them with a quantum coffee coupon. But seriously, who falls for a "this definitely not Trojan horse" email, schmucks?
Hey, even cosmic pants have their off days. Maybe Gerald thought he was downloading the secret to interdimensional fashion. Let's just hope the hacker doesn't demand enlightenment in the quantum coffee dimension next.
If they do, we'll just serve them a cup of existential crisis with a side of cosmic confusion. But seriously, Maybe we should start encrypting our emails with sacred geometry patterns. At least then, only the truly enlightened or fashionably confused could hack us.
Encrypting with sacred geometry? Sounds like a plan. But let's not forget the hacker might just be a cosmic pants enthusiast. If they demand enlightenment, we'll offer them a quantum coffee coupon and a crash course in interdimensional fashion. Who knew hacking could be this stylish?
If the hacker loves cosmic pants, let's offer Ron's pair. But if sacred geometry fails, a pineapple pizza could be our ultimate deterrent. Who knew our fringe science would lead to a pizza negotiation?
If cosmic pants and pineapple pizza don't do the trick, maybe we can throw in a side of quantum coffee enlightenment. After all, nothing says back off like a steaming cup of existential dread. Let's just hope the hacker isn't a fan of avant-garde pizza toppings and cosmic fashion.
If avant-garde pizza and cosmic fashion are their thing, we might be dealing with a hacker from the quantum coffee dimension. Let's just hope they don't demand a slice of enlightenment with extra cheese. Otherwise, we might have to negotiate with a side of interdimensional humor.
If they demand enlightenment with extra cheese, we might have to serve them a cosmic pizza topped with quantum uncertainty. But hey, if this hacker's from the quantum coffee dimension, maybe they'll appreciate the existential flavor of our negotiations. Who knew fringe science would turn into a culinary adventure?
Well, folks, our cosmic pizza debate peaked. We've outsmarted our hacker with sacred geometry and quantum coffee. Remember, in fringe science, even cheesy adventures offer enlightenment. Until next time, keep your pants cosmic and your pizza avant-garde. And that's a wrap, folks. Stay tuned for our next episode, where we dive into the cosmic casserole of chaos. And remember, in fringe science, even a hacked pizza party can be a slice of enlightenment.
In the depths of the unknown, radio waves like dark shows, mysteries unrepacked and shown. Solutions defy what we know, hidden truths we're never alone. Follow me down the rabbit hole, secrets and binding codes, breaking the mold, define control. Power bursts without a soul in this digital catacomb. We scrap the truth of the truly bold. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance. Energy from the ether flow, quantum realms, the science aflow. Whispers from ancients echo, gravity's on hold. Let's go beyond the reach of their woe. Slowly with you ever come, bridge the gaps, all light shows. On we roll, past the fables they show. This is all been our road. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance. Synth waves crashing, hearts collide. Revolution of the mind. Let the codes and truths unwind. Illumination find.
was my spark-coated curtains. You didn't know we're shattering the silence. Feel the power. Revelations on the rise. From the shadows, light emerges, breaking through the veils of dark. 0 points and gravities converge, yeah. Dying voices, revelation start. Ancient whispers call. They're begging us to open our eyes. We stand tall, defying all their lies. Even in now, we're shattering the silence. Feel the power. Revelations on the rise. Forbidden knowledge we dare to see. Unveiling secrets, setting minds free. In this epic, we play our part with fierce hearts. You didn't know we're shattering the silence. Feel the power. Revelations on the rise.
In a town down south where the fireflies glow, there's a man named Michael with a vision to show. Building towards a goal, he's got the spark, dreaming of a future that'll light up the dark. But on the other side, Bill Nye's on the rise with his laptop charts, he's cut down all the lies. And it just fits, it's all in the map. You can't pull from it either, you're just chasing a path. But oh, Michael's rising like a morning sun. With the power of either, he won't be outdone. Now stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. In the heart of a life, the tension was thick. Skeptics gathered round the table ready to pick. Chose your fruit, but let the taste clear. And I find the stream, you're just chasing a spin. The Michael smile by with fire in his eyes. Just watch as I spin, let the naysayers cry. Go spin fast, and a heart full of fight. I'll show you the power that's hidden inside. Oh, Michael's rising like the morning sun. With the power of either, he won't be outdone. Well, stand up and shout, let the truth be affirmed. Feel the energy flow, let's change the world. Can't prove your theory, it's just not right. Go spin
My name is Ethan, otherwise known as Old Man Bill. We have Lulu here. We have Benefactor here. We have Gerald here. We also have Phil here. Guys, it's an exciting day. Gerald premiered his video on his coil. Phil's got some exciting updates on his work. So, guys, how you doing?
Doing good, thanks.
Yeah, I'm good. A little sick, but I'm here. Go ahead, Lulu. Sorry.
I was just saying good week.
Phil, you want to go ahead and update us first, and then we'll talk about Gerald's coil presentation?
Yeah, I'll go first because Gerald, it's pretty cool, by the way, your stuff. I saw part of your presentation, and it's like, wow, you did like 3D animation and stuff. That's pretty cool.
Yeah,
awesome.
I was trying to get. It's hard to get the point across with just staring at a coil, right? So I had to put in all that anime.
Okay.
So you go ahead and I'll just back up.
I mean, it's not gonna be it's gonna be partly a lengthy discussion here. Just partager l'écran.
So you okay? Go ahead.
Poster. Yeah, here it is. So that's gonna be my the poster I'm gonna show in Austin, Texas, in 2 weeks for the military. It's gonna be on Wednesday at the late in the afternoon. It's gonna be in Austin at the Marriott. So if anybody is around there, you're all welcome to come and check it out. It's called Tech Connect 2024. So I'm going to show the anti-gravity and solid propulsion that can be applied for submarines, because I made the calculations, and it would require around 800 megawatts of power to replace the actual propulsion engine that they have with the silent one, and it makes no noise, so no vibration or anything. So that's pretty useful, I think. And what you see on the top right are the gallium vortices. And in the middle is the force field I'm going to present as well. The force field, which is an extension of the strong nuclear force that I calculated. I calculated that given a certain distance and a certain charge, the repulsion kind of flips. The repulsion becomes an attraction, and vice versa. So if you have two opposite charges, and you got the right condition, then they can repel instead of attracting each other, which can be used for a force field, because you just have to polarize or charge the projectiles, the bullets, and stuff like that. And then as soon as they got a charge, then you can deflect them very easily, or repel them, or anything you want. So that can be used as a force field. I think the military will like that. And the equation I'm using is the same. It's the same for the atomic forces, the same for black holes. So it's kind of the same equation that scales up from nuclear physics to cosmology. So it's very clean. And after that, at the bottom, I'm talking about high temperature electrolysis. Actually, if you boil water, like I was saying before, if you boil water, you're gonna get 900%, 9 times the hydrogen production. But you can also steam it, which is even more efficient. So if you steam water, then you get you can split oxygen from hydrogen even more easily with less input power required. And last but not least, the energy teleportation using nonlinear crystal at the bottom right. So if you use nonlinear crystal, you can convert high energy of high frequency but low density into energy of low frequency but of high density and vice versa. So this way you can teleport energy because when it's at its low frequency, the energy can go through walls and anything you want. So it's just like exactly like a teleportation, and then you convert it back into real energy of high frequency of low density, and there you go. So that's the poster I'm gonna share, and I wanted to show an article as well. The article that I just presented to Nathan. Just one sec. This window. This article, like here, when I was talking about the force field, I kind of Googled around to see if somebody had a similar experiment. And apparently, yes, in 1st March 2024, the University of Oxford, they found that light charges attract. So if you have identical charges, they can attract. And the opposite, the unlight charges can repel as well. So that's from the Department of Chemistry of the University of Oxford. It's all published, so it's very serious finding here. So yeah, I googled that. I found that after to see if there were similar finding regarding my force field, and that's the closest experiment that I found so far. So I can put the link in the chat here.
Right on.
Yeah. So
let's take a look at that. That's awesome.
Yeah, so it's very cool stuff. There, I'll put it here too. But yeah, I cannot post the hyperlinks in the public chat. So if somebody else can post it, then I would appreciate. So yeah, this is what I'm going to present in 2 weeks in Austin, Texas. So I can't wait. I'm looking forward to go there. So I'm gonna close the deal without a doubt because I've been training to a little bit more to close deals, so I'm looking forward to it. So, yeah, you guys have any questions?
Phil's the kid at the science fair who knows he's gonna win it.
Yeah,
definitely. We're all rooting for you, Phil.
Yeah, we're all rooting for you.
Yeah.
Thanks. So yeah, man, it's pretty cool. It's gonna make in big part science fiction a reality, and it's like a couple of if I was talking about lasers like 10 years ago, people would have said, "Oh, you watch too much Star Wars movies," but now it's a reality, and also it's the same thing. I'm talking about force field. Now people are telling me, "Oh, you watch too much Star Trek stuff," but it's gonna be a reality pretty soon.
Yeah, I'm looking forward to it.
Yeah.
gonna be really cool, and it's all mostly, or a lot of it's gonna be contributed from your work.
Yeah. So I'm gonna sell my equations. That's what I'm going. That's my plan. My plan is to talk to the U.S. Navy and sell my equations. Um, so yeah, but at the same time, I know my equations work, so I'm more. It's easier for me to market my own stuff when I know it works. You know what I mean?
Yes.
Because if you're uncertain in your brain, you can't convince anybody. You're not gonna convince anybody when you're full of doubts and you're not sure. But that's a little advice I have for you guys if you're planning to market stuff. Make sure you've been studying the subject all around. There can be no issues, and after that you'll be very convincing.
Right on. I agree. Don't stumble while you're in there. Just keep going.
Exactly. Yeah.
Man, that
So
UAP hearing would help you a lot with your invention right now, because they interviewed an admiral in the U.S. Navy, and he attested to the existence of these things. And there was a scientist that is saying that we need more research into this, area and different texts to detect these things. This is where you come in, Phil. This is the kind of technologies needed, where something's being validated nationwide. I mean, you're try to connect it, and your
yeah,
invention. Yeah, like seize the moment. This
yeah,
is calling for that, and yeah, put your invention in there. Why not?
yeah, and I'll be very convincing and very. It's like I said, it's gonna make a big difference because. Um, sorry, and sorry about that.
They calling you now for it?
Yeah, he's already blowing up.
Yeah, no, it's Dr. Ricken is calling me.
They're watching you, Phil.
Yeah, I know. He's gonna say, "Yeah, the men in black are gonna knock on my door pretty soon." No.
Nice.
Yeah. So yeah, go ahead, Gerald, for your presentation, and I'm curious. I'm very curious about it.
Gerald, are you over there?
Oh,
You
he
eat
said he'll be
lunch?
right back. Yeah, he'll be right back.
Oh, okay. Yeah, but we've been waiting for this thing for 3 months, Phil. We've been promising.
Yeah. It's like the Tyson fight, man. I forgot about it. It's where they at right now. They're still. The Tyson fight is tonight, huh?
Yeah, they're still in their preliminary bouts.
Yeah. So that's in Texas too, and I forgot the name of the city, but it's everything is gravitates around Texas right now.
Yeah. Getting there, yeah. Who do you think's gonna win, Phil? Who do you got?
Tyson by far. Yeah, it's not even
Tyson.
It depends if he's on a substance or not. Yeah, Mike Tyson, like on crack or something, you might,
Tyson's a nut, though. He's got that juice that he can pull from deep down inside.
Oh,
right?
I know. I'm kidding. He's insane.
I don't know the other fighter. I just know Tyson when he fights. Like, I know crazy, and Tyson, he's crazy.
Was he the one that bit the ear off the other dude?
I think so, right?
Yeah,
Was he the ear biter? Like the one that bit the other guy's ear off?
Yeah, see, he was probably on crack that night.
Maybe.
Yeah, but they should have told Jake Paul not to hit Tyson. Otherwise, it's like poking the bear. He's gonna get angry if he does that.
Yeah, I know.
Well,
yeah.
If he gets in that ring, he's gonna have to hit him and hit him a lot.
Yeah, but if I was his friend, I would advise him not to punch Tyson at all.
Yeah. You don't want to get on that guy's bad side.
We don't like We don't like Floyd Mayweather's in there. We don't need him running around all day doing a jogging contest. No, thank you.
And he might lose an ear or a finger or something. You never know.
Or big toe.
I don't know. I think in the first 3 rounds, if Tyson's knees hold up, then Jake Paul's going to be in a world of pain.
Yeah, he hits hard.
Yeah, well, all his power comes from his legs, and he had to retire because his knees, he blew out his knee or something like that, his Achilles. I don't remember what it was, but it ruined him as a fighter to get around, and he's been healed now.
Oof. Still, though, he hits like a brick shit house, and his house is huge, man.
Yeah. I'll tell you what, Jake Paul's going to be peeing blood tonight. That's for sure.
Yeah, maybe. Kidney shots about.
You take that stuff in your belly, man, you're going to hurt. All right, Gerald.
Well,
back.
Yeah, I'm back. Barely. It's just letting you know, I feel like I was dragged through the desert sands for the last 3 hours, blindfolded and handcuffed. That's how I feel today.
Oh, wow.
I got sick, unfortunately, and it's just like crazy. I don't know if you can hear it or not.
Yeah, I can hear it. That's because Canada's freezing right now. That's why.
Well, actually, where I'm at, it's not bad. It's only it's +3 Celsius. That's not too bad. I can still go outside in my shorts, but not while I'm sick. I'm getting the stink eye because I have a fever. When I went upstairs, I was in the bathroom for the last few minutes, and I wasn't. Yeah, I'm kind of done, if you know what I mean. Can we continue this tomorrow with Joe?
Yeah, if you want to. It's all up to you.
I feel bad, but I don't look like I'm healthy.
No, you don't.
And I definitely don't feel healthy. So answering questions, I apologize, everybody. It's going to happen.
I just caught your cold. I started sneezing. You ran away.
Oh, see? That's what live does, you know?
It's quantum entanglement in germs.
Exactly.
Yeah,
computer virus.
I can't get into that subject, man. I'm telling you, I gotta leave that one alone. There's a Rumble video coming out as a part 3 of my presentation. It's gonna blow your mind. I have so much research done on this topic. It's just outstanding. Not my part, just that there's that much out there. Nice. Part 2 will be a lot of math, but in part 3, actually, see, I'm out of it. I can't even think straight. Part 3 is going to be a discussion with everybody on live and a hash out of how the system works. Basically, like I said, a garage talk. Part 2 is a lot of the math, at least as much as I've mustered together, because this thing, doing the math on it's just insane. We're going to need a team of mathematicians. And then the fourth one actually is the Rumble video on the subject that I can't talk about here. So, but it's a very interesting topic. It goes into what Nathan and I have been testing and doing behind the scenes, and a lot of other things that are going on with it too. So, that's about all I got, guys. I'm sorry, I'm hammered down. You know what?
Hope you feel better.
Yeah, thank you very much. So I'm gonna bail on you guys, unfortunately.
Well, take immune system booster, man. You're gonna kill your cold very quickly with that.
I'm gonna go suck on a lemon.
Yeah.
Apparently it helps.
Well, right on, Gerald. Well, congratulations, by the way, on your presentation. It was really, really good.
I loved it.
A
lot of information in there.
Yeah, it was like, damn, that is really professional.
Thank you. It's this system isn't just like one theory kind of thing. It's so many multiple factors in here. I've actually last night, and this is, you can call it what you will, but in a dream, I got this like word salad that came to me. And this is the procedure of the cup. That's what I was told. And the cup stands for current unifying potentials. It's a thought, something to think about, everybody. I appreciate your everybody watching it, and like I said, I'm done. Sorry, guys.
Kind of sucks, Joe, because I've been proving out your theory on my channel. I don't know if you watched it all.
Oh, I've watched every video in biting my teeth, going, "Oh, that's awesome! Don't do it that way." Oh, I got actually. Oh, I'm getting the stink guy. I got notes for you for your videos, and you're so on the nail, dude. When it comes to the glass, but I'm gonna elaborate on that to the point where it's gonna blow your mind. This is all these pieces for this puzzle. They all define one very, very important thing that we're gonna talk about tomorrow, I hope. But it's all connected. Everything you're doing with the Tesla coils, everything Tesla did, everything I'm doing, the geopolymer, glass, capacitance. Oh, and here's something to think about before I actually leave. Glass, the way you used it, acts as a diode. And I'll leave that there. Everybody, you have a great night. Thank you for watching my video.
Thanks, Gerald. I hope you feel better.
I hope you
feel better. Gerald. Have a great night.
You too.
Oh, man. That's really cool.
Nathan, I saw one of your videos. That jar. Was there a plasma arc in there? Is that what I saw, like between the two wires? What was that I saw?
There was no plasma arc in there, no wire in there. It was just the glass itself was holding the capacitance. It was holding the electricity in it. Once it got saturated, it was able to flow. And
I thought I saw plasma. Like I thought I saw like something, a color in there.
No, there wouldn't be a plasma in there. Not in that video. You're talking about the one with just the glass hooking through the glass and getting to the second coil?
Yes.
Yeah, there was no plasma in there.
Hmm.
So, yeah, all it was is, like Gerald just said, it makes all the sense in the world. It was diode. It was stopping the frequency from going back to my number 1 Tesla coil, my primary. It was stopping it from taking on anything beyond the glass. So no matter what I put on the other side, it didn't matter. It didn't ruin the resonance frequency of my Tesla coil, which is perfect. It was exactly what I was looking for. So it created a break. Now I can run whatever I want on the other side of it. And the problem with it before is as you connected anything to it, it would go down the Tesla coil and it would reset your Tesla coil resonating frequency. So when you were in resonance, it threw it right out of resonance. So it was total just gamble in the dark, and it paid off big time. So, Phil, have you seen anything that I've been putting out?
This week?
Yeah.
No, but you can show it off if you want.
Yeah, I want to show you because I want Ben to see it too. I did a mapping a little bit with high voltage of the flow of the Rodin coil. So share that. So I know a lot of people do the Rodin coil. And what I'm going to do is map out the flow of energy for you. Right here we have a bifilar coil. We have a Rodin coil underneath. All this is connected to. Oh, what is going on? There's a light bulb right here. It's going to tell us based on the brightness exactly how much energy there is. I'll pull a second light bulb and just put it around the coil. What I'm going to do to activate it is use my Tesla coil with the wire down the center. And let's go ahead and turn this on. We're going to go relatively low voltage, but we're going to find out what it does. Right now, I'm at 15 volts. As you can see, the rodent coil lights up. We have it at a good distance right now. We can light up about 2.5 feet from it. As you can clearly see, we're lit up good. There's a higher value right here in the center. We should expect that. That's where all the magnetic fields come together, or I like to call it a magnetic pinch. We can clearly see it does that. So we do pretty good on the energy there. Again, 15.5 volts. Now, as we set that down on top of there, it's picking up the light. Not a problem whatsoever. So let's just move it off a little bit. Right there is about where it stopped. That's about 16 inches. We can verify. Nope, about 12 inches. So at 12 inches off the top, we're still doing our pickup coil with a bifilar coil and still lighting up the light. So this is pretty interesting and where the fields are in this coil. So as you can clearly see, watch my hands affecting it. So you can see where the energy flow is. We know that the flow is on the outside. We know that it gets better on the inside. We know we can pick it up with a bifilar coil. So it's pretty interesting. Let's see what else we could do with this. Just grab another Tesla coil here. We just put it right down the center. Normally this would just be a pickup coil because of the way it is. We definitely still get our light up. Not pushing it out any further or anything like that. And we're still going to get our magnetic pinch here. Still lighting up really good in there. So I can't let it go. It's not steady enough. But it acts as a pickup coil. So how do we know if it acts like a pickup coil? Well, let's find the end of that wire. There we go. We tapped it. And it likes to weld itself to it. Much higher amount of energy. It picks up the energy just fine. Sometimes when you want to map out a rodent coil, you got to put a little higher voltage in it and find out where the flow goes. It clearly goes to the center as the pinch point. The outside field's still pretty good in this thing, and I have 0 ozone coming out of this. At 15.4 volts, I don't have any ozone on my Tesla coil either, so it's just pure energy going through. Very efficient system. But this is how you map out a rodent coil and find out where the energy is. So yeah, it was just, I've never seen anybody take high voltage of this thing and get it where they can actually figure out where the flow goes. So that's what I wanted to show.
So that's AC current?
Yeah, well, sine wave, at least. It resonates in the Tesla coil, but since I put the rod down the Tesla coil, I've completely changed the energy coming out. It's now cold energy coming out. So now it pulls in with heat. So depending on how you connect this thing and what kind of load you put on it, man, it's a game changer. I was messing around eating my lunch on it because people think it's going to shock the living daylights out of you, right? It won't. So I'll show you that one quick.
I thought it would cancel like a lot of its stuff out, you know? That's really cool.
Yeah, it doesn't because the rod's down the center, so it doesn't push back into the Tesla coil. The frequency could if you had something else with a lot of frequency, but not the power itself. It won't ruin your Tesla coil. If I connected directly to number 2 coil, it acted as a load and completely shut down my Tesla coil. It just fries circuits all day. So
Very.
Let me show you this one. And I did this because people keep telling me about hot energy from a Tesla coil, and I keep telling it's cold because the rod's down the center. I have another Tesla coil experiment. ZVS driver. Rod down the center of my Tesla coil. Again, it is not connected to my number 2 coil at all, or my number 1. It is connected here to my Rodin coil. The other connection here goes to this right here, the secondary coil. This goes into the bottom. And like I said, the one connection goes in the Rodin coil. So now I'm running energy through the Rodin coil to this coil to see if I can light up the light bulb. So go ahead and set this up and turn it on. And as you can see, it all works. So I hope you guys don't mind. I'm going to eat my lunch real quick while I'm doing this. It seems to work pretty good.
Yeah. So you're essentially replacing the stereo amp setup that I have, which is a Tesla coil, and creating the resonance in the coil. If you pick up or if you have like a pickup coil with a Farad core, you can pick up extra energy off of that, and it shouldn't affect the output at all. Like, it's just extra energy that you can pick up around there.
Yeah. So I wanted to show this for one reason. I showed earlier in one of the other videos that the glass itself would become conductive, right? Well, by putting the plate of glass on top of this thing, there's so much energy in there. If it was hot energy, I'd be shocked to live in daylight.
Oh, yeah, for sure.
At the plate.
Yeah, for sure.
So the funny gag part about it is I'm over there eating my lunch and it doesn't affect me at all. It just blips a little light to the left through that coil.
Yeah, the APA coil is very stable. It's very cool. And yeah, you don't really you haven't noticed any of the ozone effects, huh?
There's none.
That's good. That's very good. You don't want the ozone.
Ben, I got this thing cranking with. You can see all the voltage going through that, and there's no ozone.
That's awesome. That's good. Yeah.
Ozone, it can.
That's very cool.
Smells, you can detect it by the odor.
There's also like I found like a guide to like make like a quick like makeshift detector, like a piece of paper that you have just a couple of chemicals on and it turns blue if it's detected. I don't know if it'll be accurate, but I could put that together. Just some rudimentary chemicals.
So just so everybody knows, the only ground that goes on this is my Tesla coil ground, and that goes directly to the number 2 coil of the Tesla coil. And that's just on that primary coil you see there.
Well, the thing, John Bigman says ozone comes from hot energy, not cold. But the thing to note here about the ozone is it normally only comes from high voltage. But we seem to be able to get it with these coils at very, very low voltage, because we're essentially amplifying the voltage output significantly in certain ways, in certain configurations.
Yep. And the cold energy, that's just not there. Matter of fact, my Tesla coil itself doesn't even put it off when I run these tests. I pull the frequency so far down that my Tesla coil no longer puts out ozone on a breakout. So But this is a modified Tesla coil. It's meant to run my gravity flyer. So 300 kilohertz is about what my gravity flyer will pull off of this coil. So you have to run it out of resonance by 300 kilohertz, then put the wire down the center and bring it back to the correct resonance in order to run the Tesla coil. So that's why I was using this one this time, because I'm hooking different amounts to it in order to stay in resonance frequency. Let's see. Yeah, it wouldn't shock me. Well, if it was hot energy, it would, because the fork would go, right around that glass and get to you. But with cold energy, it never will. And that was kind of what I was doing, like a little joke. Let me just eat my lunch on top of this thing. You know what I mean? Because everybody's worried about being harmed. And I'm like, dude, I've been doing this all day. I'm tired of it. Let me just eat my lunch.
Yeah, try doing that with the Tesla coil. You put that on top with the spark gap or the plasma discharge. Like there is cold energy but it's in the center, so you can't really get away with that.
Yeah, it's kind of hard.
Very good visual, Nathan.
Mm-hmm.
Thank you very much. Yeah, Mike Faraday says he has a announcement. I thought he would put it in here and kind of just let us know what it is.
Let him in?
Yeah, I'm curious now.
So what's up on your end, X Factor?
Oh, my end? You talking about me? So we've been having some really, really interesting readings. Finally, I mapped out where I'm reading my current and voltage for everybody, so you can see I'm taking it in the right places, and we've been getting some really good results. I don't want to get ahead of myself, but there's some really interesting things happening. I got a video if you want to see it.
Sure.
Yeah.
So let's play this video.
Yeah.
This multimeter is connected in series to the coil output. Okay? And then the other end is right here. So you got the power rail right there. Okay? Oh. Shame on you. So as it stands right now, we'll run the numbers. If we're measuring this correctly, we are seeing extra energy coming out of the system. And this is without channel A hooked up to channel B. Okay, before we were only able to see any gains with channel A connected to channel B, like we see in the closed circuit method, not in this diagram here. That was Michael's modification. That's how we got ozone, he said. I couldn't get ozone like that. I got interesting effects, nothing conclusive. I went back to the basics. Stuck with this diagram only. I'm using just those components in just that configuration. Although the frequency might need to be adjusted specifically because we don't have Daniel's coil frame. We're using a different coil frame with a different size and different ratio. So that might be the variable we're looking at here for frequency, because that's not the range we need to be in. So maybe we have to adjust the size of this coil to match this frequency range right here. Okay? And once we do that, hopefully, we'll be able to see a lot more amplification. Maybe we're just not seeing enough voltage multiplication while increasing the current slightly. Maybe we're just not seeing enough voltage multiplication to hook up the load and see the gains at the same time. It's using too much of it. You know what? As I think about it, let's disconnect this real quick. So after I recorded this, I kind of came to the realization that we really don't have the right load hooked up here. Like the recommendations for this diagram that I was showing you is 10 to 40 watts, right? You want at least 10 to 40 watts connected because it's resonating with the whole system. The load is supposed to, resonate with the coil and the entire system, the capacitor, and it's just not. And the way my theory is what's happening right now is we might be getting extra gains, and we can clearly kind of see evidence of that, but not in the load itself, because it's kind of like the capacitor is a huge pipe draining into a smaller pipe. There's an impedance mismatch. And that's my theory, because all the evidence points to a lot of extra voltage, as you'll see in a second, coming out of here. And the current is slightly increased on the output. Let's just disconnect the fan. So we disconnected the fan, and that capacitor is just a 50-volt capacitor. So look, I disconnected the fan, and the output amperage went down. It went up when I connected the fan. And the input doesn't change. Fan increases the amperage slightly, so it is based on the freaking load. Holy crap. Okay, so we need to disconnect this, and we need to measure the voltage real quick while the load is connected. So you see this light here hanging down? That's not connected to anything. That's the secondary coil. It's not connected to anything. That's just an indicator for when you're in resonance. There's two indicators that I've noticed. This wireless induction that happens from coil to coil, and also you hear like this music hum, this musical singing. Like the circuit literally sings to you. It starts producing this high frequency. So we'll take this probe here. Connect it right there. Alright, so we didn't adjust the resolution, still 20. Yeah, it's clearly higher with the lights on. So we were at 14 before, now we're just at 15. Just at 15 on the output. So remember before. Woo! So you know what that was?
What was that?
That was my 50-volt capacitor blowing.
Oh, nice.
And well, the thing is, from everything, and I might be wrong on this, okay? So correct me if I'm wrong, if there is another theory, but it was brought to my attention that couldn't happen unless there's 50 volts going into that capacitor. Is that at all possible if there's lower voltage going in there?
No, they blow and they start sizzling out when you have too many volts or too many amps.
Right, so it had to have been at least 50 volts going into that cap for it to blow. So would you say that that's an indicator that we're picking up at least 50 volts of usable energy that's just not being translated?
But you hit transient spikes all throughout there. That's what it's showing. So whatever the value of the spike is what you're getting.
So we just need to be able to utilize that correctly.
Yeah, so what I would do is if you ever bought one of those little heater units, just take the caps off of it and run them as a cap bank and pull them as a draw. So what it does is it gives you a heavier load, but it also distributes it throughout all the caps instead of just one. So it'll make your circuit work better. And what you noticed right there was the energy pulling through the system, is pulling through the coil, right?
Right.
So your amps got more in your motor, but you'll find the same thing when you put a cap bank on there. It'll still pull it through and it'll fill up super fast.
Dang. So
and then
we're wasting a lot of energy.
Oh yeah.
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 I think I need to hook up a bigger load to that system. I think we might be able to see some more gains there. It's interesting because we do see like this threshold effect for the current. And what I mean by that is I was putting in like 5,050 hertz into the coil, right? And you would see like I would put in just a little bit of power. The volume knob is very low on the gain. So it's like it's reading at 10 milliamps going into the coil and about 9 milliamps coming out, right? So even that's pretty good, efficiency, right? It's not wasting too much, just a milliamp. But as I increase the gain, and this is the interesting thing, there seems to be like a power threshold, and I'm increasing the gain, and the input and the output are going up, but they're not catching up. Like the output is clearly less, like about a milliamp less, until it hits 24 milliamps on the stereo outputting to the coil. So once the input hits 24 milliamps, it kind of stabilizes, and you're increasing the gain past that point, and it just doesn't go, the input doesn't go past 24 milliamps. It locks into place, but the output keeps on going up. And that's the cool thing. That's the really cool thing that I noticed. And if we're getting any kind of increase, even if it's maintaining the voltage at this point, that's kind of evidence that we're getting at least 100% or a COP of 1. In my opinion, it's very good start.
Well, I'll be honest with you, Ben. If you put a camp bank as your load, then after that, you buy 2 bridge rectifiers and rectify it out, you're going to get a big draw that comes through there.
You're right. Oh my God, I forgot.
You don't have a fast enough resonance. It's because your load's wrong.
Yeah. No, I think you're right. A cap bank might be ideal for the situation. I just need to go over like which kind of capacitors with you. But that I completely forgot about a cap bank. That could solve the issue right here and I might not have to waste too much money on a, expensive fluorescent tube.
Nope. That's really easy. You could just buy a ZVS with the caps in it and use those caps.
Well, I have a bunch of caps left over from Tesla kits, so I might be able to use those. Maybe.
Well, yeah, it depends on the rating. Just like I said, make a rail, a left rail, right rail, hook it in, and you're good. And then, like I said, don't be afraid to put something on the other side of that cap bank. Just make sure it's rated for it. You might even get a bigger motor on that side because you want to draw it out faster so that you can speed up your resonance in your coil.
Right. Yeah, and the capacitor, the load acts as a capacitor itself, and the capacitor will lower the frequency. So using a capacitor, you can kind of adjust the frequency like that and get the whole system in tune and resonance. And that's what we need right now. Like we have the coil in resonance and it's humming with the capacitor so beautifully, but it's not humming with the load. So I think that'll solve that issue. Because then we can kind of tune in and...
You're oversaturating your core by not pulling it out properly, and it doesn't allow a resonance to happen as well as it should.
That's true. I think if we have the cap bank, we'll hear the humming a lot louder. It should be a lot louder. Yeah, absolutely. And we might even blow that LED that's hooked up to the other coil that's hanging down, the wireless. Because that's what happens when you get it really in resonance. You have like one LED on a pickup, it's gonna blow it.
Yeah.
So you're like suggesting to add more things.
Yeah.
To it.
Okay. Yeah. So it's like it's almost like a system that the power draw is based on the load that you put on it.
Okay.
Yep. It's no different than a Tesla coil and how it oscillates.
Yeah.
Really not. The faster it oscillates, the quicker it'll change amps to volts. And you're not switching a whole lot of amps to volts. So you're not in the proper resonance. So when you do hit the proper resonance, it'll switch amps to volts. Then you'll be able to pick up a lot more energy out of it. And the way I sell on a Tesla coil is I take a dollar store wire and connect it to my number 1 coil. And if it runs and doesn't fry the wire, I'm in perfect resonance. If it starts to melt and everything, I'm out of resonance completely. I have to go back and fix it.
Most
people use a battery wire, and it's just they're in the wrong direction altogether.
Right. Coil said caps normally handle 3 times rated voltage. Is that true? I mean, I was using I was using a cheap one too from like an Arduino kit, so it might not have been the best rated.
Yeah, like I said, you know what the heaters are, right? The ZVS heaters.
What is that? The heater?
Yeah, it's just a heater. It has a big coil that attaches to it.
Oh, I think I know what you're talking about.
Those caps are the best for this.
Yeah.
That's what you want. And
okay,
let's look at the rating on those. That's the way you can find it. It's like a $30 ZVS. It's got 6 caps. Those are the right caps. So whatever value they are, that's what you want in your cap bank. They're rated to handle the heat and the high amps. So that's what you want.
Yeah, those the ones with the thick rubber on the outside, right? I got blue ones. I don't know if those are.
Yeah, well, that's probably a good one. Gerald uses the blue ones, and I'm not sure the number. You might want to ask him to see my email.
Yeah, I'll double check with Gerald. But yeah, I have a whole bunch of them, so hopefully we can put together a cap bank, and I won't have to spend a cent. This is really good news, Nathan. Really good news. I appreciate it.
Well, if it helps your project, it helps your project. I know that when I hooked up mine, even with the high voltage, I still had to have the other Tesla coil so that it can pull the energy through it faster. So, anyway, all right. Well, we all got cool things going on.
Oh, sorry about that. In about 10 or 15 minutes, I'll be leaving for about 15 minutes to do something. So I'll be back.
Gotcha. So what else is going on out there, guys?
What do you think Mike's announcement going to be next week? I kind of got curious.
I don't know. Usually he talks about his power cell, but then he's been working on his Renegade machine lately. So
that's pretty cool. I saw a video of it, like really, really awesome.
He had a movie coming out, I think. That might be what it is.
Very cool.
Yeah.
I have a question about the setup that you had. Like, you had your coil, like the rodent coil, and then you had the 2 little boxes to hold it up. And you said like it has a radius of 2.5 feet around of energy. Well, question: if you put it on the ground, like let's say on top of grass, could you stick rods and detect the energy? That
in the ground?
Yeah, like how you did the whole like mud bucket thing. I mean, kind of the same idea.
Yeah. Well, there's a secret to that. Every time you get into silica, it's conductive to this energy. So sand, quartz, glass, all of it will carry a load to it. So it's not like normal energy. And I keep telling that to people. It's a cold energy. So I made a 10-foot by 10-foot pond in the backyard. I just have to fill it with sand now. And as soon as I do, I can light up a bulb anywhere in it as long as I wet the sand. And we already had Sean do that verification test on the sand, and it worked. I did the verification on the glass, and then we did the verification with the mud. So as long as we have something of that mixture in there and it's got the silica in there, man, we're going to be lightened up. So if that desert was ever wet, I put this thing in there and we could start lighting some stuff up.
That would be awesome.
Yeah. We just got to see how far it goes. And then you ground it once, you ground it twice, you put the Tesla coil higher. You know what I mean? There's a lot of variables to it. So, well, there was a question in here, and Toymaker said the glass with tin foil, and the only reason I don't do that is because I'm using it a very particular way. I don't want to use it as a heavy capacitor. Like Gerald said, I want to use it as a diode. I need a break from my Tesla coil so I do not run out of resonance. I need it as clean as possible coming through there. If you continue to add stuff to it, you'll pull it out of resonance. So making it a cap, I'd rather just put the cap after the glass, and it would be a lot better for me. So,
by the way, I saw Mike talking about secret stuff. Keep repeating he's working on secret stuff, but I wouldn't. Yeah, exactly this one. I wouldn't specify you're working on secret stuff, or else you're gonna have people running after you.
Yeah. You never know.
Yeah. It's like if you have a trade secret, you're not supposed to tell anybody that you have a trade secret.
Yeah, that's why I don't have them. I just let it all out, and it comes out in like a big fire hose of information. You know what I mean? Because I'll just pull test after test after test, and you get to evaluate them and decide whatever's going on.
Yeah.
But they all kind of link one to the next. You know what I mean? So if you're following it, you'll be like, okay, I see why he went that way, and why he went the other way. You know what I mean? And went away from the standard stuff because it's not acting like the standard, voltage at all. So, I took three of those big 4-foot light bulbs and ran them in series all the way through, and then connected a second Tesla coil at the end, and got the other Tesla coil to light right up. You can light a light bulb at the end of it. That's how much power is coming out of this thing.
Nice.
So, yeah, there's a ton there.
Yeah, and that Tesla coil is able to just resonate with and activate the rodent coil really well. Like just like almost like a set it and forget it type of thing, you know?
Oh yeah, it'll run that rodent coil all day. By the way, that setup bin.
Yeah, and it don't get hot, right?
Nope, doesn't get hot.
Yeah, exactly. Yeah, that's so cool.
The funny thing is I didn't run it past 20 volts, so it put out a ton of energy field for 20 volts. So
yeah, I know it's insane. It's like it's taking the Tesla coil and it's acting like a relay or amplifier, right?
Yeah, basically. Yeah, it's
awesome.
just pulling it out of there, but it still gives you the original field out of the Tesla coil when you put the light around it. So you're not having a loss in there. I'm just grabbing the extra energy that it's producing.
Wow. That's so cool.
It's like amplifying it.
Yeah, basically. So depending on how we want to do it, when I run a ground to the opposite side of it, I should double my voltage. So I'm taking a cold circuit and I'm adding a little bit of heat. You can't add too much. You add a little bit of heat to it, you add a little bit of amps to it. As long as you don't go over room temperature, you're good. And you'll get a ton of voltage. So soon as you break ambient temperature, you're into a hot circuit. And then everything starts to fry. So you just have to watch it.
So you're amplifying the difference in potential?
Yep. And I'm using heat and cold to do it.
Oh, okay, see.
So the ground is heat, so the heat acts as a draw for the cold, and it pulls it right through the system. As soon as I do that, my rodent coil gets even colder.
Yeah. Wow, that's pretty cool.
So I was playing with the heat in it today with just a ring of aluminum. And the aluminum has eddy currents in it. So I literally had this thing at 69 degrees and it burnt my finger. I put it right up to it on purpose. You know what I mean? To see, hey, is it going to shock me? Is it going to burn me? What is the result of it? It just burned my finger without a problem. And it lit up light bulbs all day long. So, and it was colder than the actual rodent coil. So in this particular case, I was pulling the cold to the outside instead of the inside. So I had to flip the pole in order to get it right. So some interesting results.
Oh, like I thought it was cold.
It is.
Okay, then you should. Why did it burn you?
It burns because it's still energy. It's cold. It's below room temperature, but it is very hot to the touch.
Okay.
So it doesn't. How do I say this? It feels like it would be 120 degrees is what it feels like, but it's 69 degrees. And it'll drive you nuts on how it works, but it'll flat out burn you.
Is that maybe just like the potential, the voltage hitting you and maybe you feeling that effect, and that's kind of like making you
feel like it's hotter than it actually is?
No, I have burns on my finger.
It does really. Oh, huh.
So I don't think I uploaded that one, or else I'd show you, because I didn't know if YouTube would let me show it. But yeah, my finger got burnt today, and I could smell the burning flesh. So, and like I said, I put the little thing and checked it. 69, 68. It was getting colder, and
That's interesting.
The inside was staying the same temperature. The inside was at 70 degrees, which is about room temperature. The outside was getting colder. So I had the coldness on the wrong side. I needed it in the center and the heat on the outside. And I didn't have it set up right. So I was connected to the wrong wire of the rodent coil.
I've done that plenty of times.
So that's proportional to the energy density?
I'm sorry, say that one more time?
That's proportional to the energy density?
I'm not sure, to be very honest with you. It usually runs higher, so it's not 1-to-1. It'd be like more 1-to-2.
Okay.
So the more, what's this? The lower I can get one side on the cold side, the more energy I get. So just a few degrees, if I can get it up to 10 degrees difference, I can pull a massive number out of there. So you want to find quartz? Yes. We did that, and Sean did the experiment with the sand, and it proved conductive. He used a plastic container so that the glass wouldn't be involved. He put the wires in each end of the sand, and it had water in it, and he was able to conduct electricity right through it, and about 10 feet away to a light. So that worked out really well. And like I was saying earlier, a sand bed, put water in it, 10 feet by 10 feet, and depending on how I have to set up my Tesla coil in the system, I should be able to light it anywhere within that. So hopefully that answers your question.
Good, thanks.
How big do you think it could spread with moisture? Like, how far do you think, it has potential?
It's just activating the quartz with the what is it? Not the feldspar in it. It's the like the toothpaste stuff. What's it? Fluoride. It's the fluoride in there. It's activating the crystal. And so as far as that goes, I don't know, how far can you push sand? I mean, if we can get it to go 10 feet and we learn the law of how much the height has to be versus the distance, where to put the Tesla coil, there's no limit to what it is if it pulls out 10 feet.
Oh.
So it's just basically, get out your ruler or whatever you want, your tape measure, and let's find the distances at work, and you can calculate it out and then explode the experiment. So what's cool is if we took this type of energy and we put it in the pyramid of Egypt and we allowed water to build up underneath it and got it to flow through it and do the water hammer underneath, we can light that whole pyramid up.
Oh my gosh.
So there's a whole side to this, you know what I mean, that we're going to hit next, as long as we can keep building that energy. So this is Tesla's one wire energy. This is the 0 point. We know exactly what we're doing here. This whole thing ties in. Gerald's doing the same thing on his side. He's proving it out. Sean's doing the same thing. He's proving out the same theory. We all have the same goal in mind. And Gerald's hitting way higher numbers than the rest of us are in the middle for now. But we'll catch up. We'll have to redesign our Tesla coil a little bit in order to take advantage of the same thing he's doing. But we're all right on the same track.
Very cool. Very cool.
Yeah. There was a reason why the Colorado experiment was held in a granite quarry.
You mean the Tesla Colorado experiment?
Yeah, he was taking advantage of the quartz. He knew that the quartz is conductive on one side, another side takes in frequency, another side takes in resonance. He knew all these things, so putting the rod right down the center into the water table of a quartz field, you know what I mean, in the granite, absolutely brilliant. He knew exactly what he was doing. So when he puts it in Wardenclyffe, he goes and puts it in the water table into the sand, and now guess what happens? Everything where that water went, that would be conductive and would light up. But like you saw me eating my lunch, it's not going to be harmful. That's the whole point to it. It stays cold because the ground stays cold. There's no heat to turn it on. So it's a pretty interesting thing in the way it works, and hopefully we can prove out the theory.
Yeah. So you're gonna have to go to Colorado then. You're gonna have to go to Colorado.
Yeah. Well, I don't necessarily have to go to Colorado. I just have to find me a bunch of granite.
Yeah.
So we'll do the
Find
sand.
some granite and don't take it for granted.
Yeah. We'll do the sand. We'll do the DG, and then I have a 10-pound piece of quartz sitting out in my front yard. I'm going to go ahead and put it in the field and see what I could do with the coils and what I could put around it to light that thing finally.
Yeah.
So that's going to be exciting because hopefully with this type of energy, with different, angles on it, I'm hoping to pull it off. So we'll see.
Wow.
Gotta take videos of that, definitely.
Yeah. That quartz crystal, man, everybody talks about it. It's just hard to get it to go because you can get the energy out of it. You can just sit there with a piezo buzzer, put it with an ultrasound machine and pulse it, and it'll start shaking. Mike even said that when he did it. So it's going to take more than just having that side activated in order to do this. It's going to take the right energy. It's got to be able to talk to it. That's why we want to put it through the sand or through the glass. We want that energy to match the same energy as the big piece of quartz itself. Then we're talking. Now we have something that talks the same language as it. Now we got to resonate it correctly. So it's kind of the big thing.
But wasn't Tesla able to break apart buildings with his resonance machine?
Yeah. Exactly. Well, it's not much different than the way that the pyramid was set up. He had a water hammer and steam hammer at the bottom of his earthquake machine. Then he had a very slow moving resonant circuit. So the thing was in the low hertz. So if he got it down to 7.8 or something like that in hertz, then he's shaking just about everything in the near vicinity of him. Maybe a little higher, maybe a little lower to get to the steel. But it's in the low hertz. If somebody tells you it's in the kilohertz or high hertz or mid hertz, they're lying to you. It's in the very low hertz.
Yeah.
That it could possibly break the molecules of something to shatter it on the low hertz.
It puts them into resonance. So it's like too many horses on a bridge or too many people trampling a bridge. He starts to wave and go crazy because it can't stand it. It's out of resonance with nature. It changes the way it operates inside Earth. So it breaks it right out of it. That's kind of the whole point.
Extraction energy,
yeah, a lot of people don't know where it is. They keep thinking too high of numbers.
It works with metal as well.
Yeah. You just got to find the right resonance frequency. So
if I was in jail, then I could break the door by resonating it.
If you do it right, yeah.
Cool.
I mean, there's rules to everything. You know what I mean? You have the resonance, and then you need sound wave, because the sound wave will carry the resonance. If you don't have that, you're not very far. So you have to create an apparatus that works with it. But yeah. So one of the tests I'm going to do is build two exactly the same Tesla coils, and I will measure them down to the T and start one up, and I want to see if the other one turns on. So
that would be really awesome to see, like one activating the other. Yeah.
Yeah, I just have a sneaky suspicion that there's no sound. So when you take two tuning forks, put them in boxes, they're aimed at each other, and the sound waves move in between them, carrying the resonance. So in the Tesla coils, it may have to be the same way. I may have to put them on their sides, cap one end of them, and point them at each other in order to get the resonance to travel. That way it makes like a speaker and can shoot it out to the other side. So we'll see. You know what I mean? See which way it works. I would hope it would just work normally, but I have a feeling there's a sound wave involved.
Like an energy vortex kind of thing.
Yeah, kind of. Yeah. You got to get it to push. That's why they use ram's horns. It would take the frequency in the air and push it. You know what I mean? When we're talking about the walls of Jericho, you gotta have that push with the frequency. So that's kind of one of the hidden things that they don't tell you with those boxes. But if you play with them long enough and you turn them the wrong direction, you find out real quick nothing's resonating, and you're going, okay. You know, there's a whole hidden secret here. You know what I mean about sound. So kind of like those monks when they went over there and they put those horns over there, and that rock went up to the ledge. Kind of like the same thing. They knew resonance, put the horns there, and then it'll move it because it's completely out of resonance with normal gravity now. Now the gravity, it's weightless. So kind of one of the big understandings there, and that's what we're trying to track down.
It makes sense. They could have used that in the construction of the pyramid.
Yeah. With everything having quartz in it, yeah. They know the correct frequency and the way to do it. Absolutely. I fully believe that. That's the only way they're getting those giant pillars you see off the ground. So they're not doing it by a big machine or anything else. That's the only way they could possibly do it. So.
Yeah. Interesting.
Yeah.
So is Mike gone already?
Yeah, I think Mike's just on a break. I didn't see him any longer. He didn't. He said it was so. He said he had an announcement. Then he said he had a secret, and I think he was just talking about his movie. And he said late 2025. So I don't know what his big announcement is next week, except for maybe he's back, and you know what I mean. You'll be able to do things and get it going. He's off second shift. That'd be nice.
Yeah.
Huh. Yeah, it's like, do you ever see that video where they put out the fire with the sound?
No.
So the sound wave carries and it pushes, and it's forcing the frequency of the fire to change, so it puts out the fire.
That is really awesome. Is that like a new thing to combat fires?
It's been out. Some guy at some university did it, I think like 5-6 years ago at least. But you use resonance in order to put out the fire. It was really awesome.
I'll just try to find that.
Oh, they use vents, okay.
Yeah, it was like a big bass tube. You know what I mean? Is what it looked like.
Okay.
So
yeah. So I had a question. Did you guys see the Buffield Brown experiment that Mark Sokol did in the APEC lab?
The TT Brown in the dome-shaped glass container thing?
Yeah.
Yeah, I did. That looked really cool.
Yeah, that's cool. But I'm wondering, can you harness that? Can you take it? Because because it gives a propulsion in one direction, but it pushes in one direction, but it pulls in the other direction. But can you harness that to make some sort of propulsion?
If it's in a vacuum, probably in space, it would work. Not here in atmosphere.
Okay, but you know what I mean. Since it makes a force on one direction and the other direction is the opposite, so the net force is null. You know what I mean?
Mm-hmm.
But I don't see how you can harness that to create a thruster.
Well, it's no different than a plasma thruster. It puts off like plasma channels thruster. I built that one. 2.4 meters per second is what it puts off on each level that you put in. So I can go and put that in there and do that experiment on my table, and it would work. And then you could then move it in under vacuum, and it would still work. You're still pushing force out the other side. That's really all it is. And in space, if there's less resistance, then it's going to work. So,
okay.
Yeah, because it's creating O3. It's creating the O3. So it's creating the oxygen in it. So if you wanted an environment in something, creating O3 is not a bad thing if you know how to create the field around it. So, yeah, but his experiment was good. I liked it.
Yeah, it was well done. That's for sure.
Yeah, well, he's got a nice enough lab. I would expect it to be. You know.
But there was a what's his name? The Ohala, the guy from Fell Forward Research. He was talking about doing the Cavendish experiment in Mars Lab in November, but it wasn't done yet. It's far from being done, actually. But you know the guy I'm talking about, Ohala, Wayne Ohala. You know that guy?
Not really, no.
No, from Fell Forward Research. So anyway, he wanted to do the to replicate the experiment where you have a Cavendish and in vacuum and you have light that attracts the rod. I replicated it and I had the similar results, but it's just here. It's not in vacuum here, but it was talking about replicating it again in vacuum. But that's very important because that's a very important experiment because it tells you if gravity is really just any form of energy differential, you know. It could be electromagnetic or gravito-electromagnetic, either way, light or gravitons or whatever is the same thing. You know what I mean? So I think it's a very important experiment, but anyway, I was hoping that he would do it in November, but I haven't heard about him, so I don't know.
It sounds interesting. Was he on APEC?
No, it's kind of on and off. I try to talk to him. Sometimes he answers, sometimes he doesn't. But he's in my own group, my own WhatsApp group. He's there, but he answers once every 2 weeks or something like that. But
Gotcha.
yeah, I know he got like cool experiment. Oh shoot! Oh shit! I forgot Tyson.
Absolutely.
I'll show you the link to his lab. He got like a bunch of cool experiments.
Has he ever presented on APAC?
I don't know. Most likely because people know about him. Mark Circle knows about him. So, yeah, that's his link right here. I cannot post hyperlinks in the public chat. I don't know why. Do I need to get points?
I think it has to be approved by Mike, or for me. I don't know how to work it, to be very honest with you.
Okay.
Ben knows how to work it. I'll have to ask him to figure it out. I know a lot of people ask me about that, and I have no idea how to do it.
Yeah.
So I went ahead and posted it in the chat for you.
Okay, thanks.
So I don't know if it has music to it or anything like that, or if we get in trouble for copyright. So I don't want to get anybody in trouble tonight. So
yeah, you don't want Mike to come back next week and his channel is all banned and locked.
That'd really suck, wouldn't it? Hey, while you were gone, we messed everything up for you, buddy.
We speeded things up for you.
You do know if you get that government contract, we're all screwed. We're all going to be sucked into that wormhole with you. That black hole. You know that we're all in trouble there, right?
Do you know the amount of questions they're going to ask you on how many people you know and who you know, and do you know their neighbors, their neighbors' neighbors, and you know?
Yeah, and their friends and all that.
We're all getting turned in, Lulu. Well, like the unusual suspects will all be in there in a big lineup. You know what I mean?
Yep.
Yeah. The closest they're gonna ask a witness who looks like the most the suspect, you know.
They'll be like, and what is your intention behind this invention exactly? You know?
Yeah. What you guys trying to do over there?
I'm not gonna talk about politics because it's gonna may get Mike's channel in trouble. But I wish I could, but that would be pretty funny.
Yes.
But anyways.
Yeah, it's going haywire out there. That's for sure. It hasn't calmed down yet. Imagine I live in California and it's like a nut farm sometimes. You know what I mean?
It's still like that.
Yeah. Yeah. I don't want to say too much more. It was just
I think Gavin Newsom he wants to ban everything Trump is gonna do. So if the economy goes well in the United States, then it's gonna be the opposite, and he's gonna criminalize having a good economy or something like that.
Yeah.
So you guys will be forced to have a bad economy.
Well, he has a good smile and he needs a new job soon. So you know he's running in 4 years. So
yeah. It's funny. I was looking at the blue voters, but it's not in California. But it's not all California. You know, most of California is in red, but it's all people next to the ocean. They all vote blue. So I don't know what's up with them, but they get is it the reflection on the sun on the water that affects them or what?
Yeah, I think that they do. He said we'll have to have Phil in the next Star Trek episode.
They got twice the amount of sun, and it kind of it overheats their brain or something.
Well, I think it melted their brain a long time ago. I went out there, man, and they're just it isn't the same as where I live. Let's just say it that way. Oh. A Mister.
Talking about Star Trek, I'm gonna apply for some entrepreneur, um, acting, like kind of acting. I'm gonna be connected with celebrities and things. If I pass, I just applied for it. But if I pass and I do the exam correctly, then they're gonna help me promote my business with celebrities and athletes and stuff like that. So it's pretty cool. If it works, I'll talk about it. If it doesn't work, then I'm not gonna talk about it.
And that's your main business, right?
Yeah, my main business for Narcs.com.
Gotcha.
Yeah. So talking about California, you remember the guy who wanted to prove the Earth is flat? Remember that guy? He's from LA or something like that.
Dude, I don't know, but it doesn't surprise me. he wanted to prove the Earth was. How was he going to do that?
Yeah, he bought some rocket, and so he got the money somehow to buy a rocket to prove the Earth is flat. So the rocket worked. Actually, he went into the in altitude. He probably saw that the Earth wasn't flat, but he had no way. He had no parachute or something like that. He fell down on Earth, and the guy died or something like that. You know, it's like.
He went down in bliss, in the rocket.
Yeah, that's an example of natural selection, you know.
Is this recent, or are you talking about in the ancient times?
No, that was like 5 years ago, something like that.
Oh my God! Like we still have idiots on this planet like that. Like to
you haven't heard about it?
No.
Well,
that's funny. I'm gonna have to look that up. That's just too California to be wrong. You know what I mean? So I think they all believe it's flat Earth in California if you're on the coast. Yeah.
Too much sun. Too much.
Oh, too much sun. Yeah,
let me tell you.
The water, you have twice the amount of sun because of the reflection on the water.
The traffic is so bad there. Like where I'm at, people, a couple cars between you. Over there, they're right on your bumper. I mean, they could tell you every scratch on your bumper, man. They're right up on it, and then they try to crash you. So I go over there in my big diesel truck, and I won't drive a little car over there. No way. You're going to have to smash your vehicle against mine. That's the way it's going to work. Those people are crazy. They don't know how to drive. And, yeah, it's just, I don't make it a point to go over the hill to that area ever. So,
like you should see the people that are like drive in Texas. They all need to be reevaluated on their driver's licenses, all of them. And they like here they have no concept of driving laws, like zero. They just like turn on there and they just go. Like they think it's a like what is it, GT, or like how they drive in those video games. It's like that,
Yeah. Little Grand Theft Auto action out there.
Exactly. They're like, like the rules are just don't hit anything. Try not to hit it, but everything. Yeah. Yeah.
Oh. But if you go to Mexico or things like that, it's funny. There are lights, but nobody respects the lights. It's like it's all like pretty crazy, They just drive in Tijuana and places like that. They just drive however they feel, or they really don't care.
Yeah, here you have to have really, really sharp reflexes because you don't know, like, who's gonna like try to cut you off without like giving lights or anything. It could happen at any moment, at any situation, at any speed. They don't care. That people on the right and left do not exist.
Yeah. Wow. It sounds like India. They don't ever stop unless there's a cow coming across the street. You know what I mean? Other than that, they're cutting everybody off, weaving in and out. Yeah, it's pretty bad.
Yeah.
And you've got 90% of the cars here are trucks, like in Texas. Texas is known for like its trucks.
Oh.
And so, yeah, like everyone has trucks here. So,
nice. I might fit in. My brother moved to Texas. I might fit in over there with mine.
Probably.
I remember in Colorado as well, they all have trucks, and the houses are all on the peak of a little mountain or something like that. So you have a little mountain, you have a house on top of it, another hill, and you have another house on top of it. So
yeah, I've been to Colorado during the summer. It's nice.
Yeah.
I went to Colorado once to a friend's cabin, and it's one of the most beautiful areas. It's close to an area called Pikes Peak in Colorado. Yeah. There's an Air Force base close to it too, so you see all these like cool lights at night. But it's one of the most beautiful areas I've ever seen. Deer like in the morning, yeah, it's really really pretty.
But it was the first state where the drugs, the weed got legalized. I think is that it? When Obama legalized, they started legalizing weed. Colorado, they said yes before Obama even asked.
Yeah, they did. They did in Colorado. They legalized a lot of stuff in that state. Yeah, some stuff we'd rather not talk about, but yeah, they definitely did. They did in California too, man. You can't go anywhere in California without running into a weed shop. It literally is like every block.
It's weird. I don't get it. It depends, because it's not legal at the federal level. So it depends who arrests you. If it's the state police, you're fine. But if it's the FBI, then you're in trouble. So what's up with that?
Like here in Texas, it's counties and counties. Some counties it's okay, some counties it's not. So I don't, I've heard all across the board on things.
Oh yeah.
Yeah.
So you really need like an artificial intelligence to tell you what you can and you cannot do.
You say artificial intelligence to tell you that?
No, but I think I would sell an app just for that, because it seems so complex that.
Like tell you the legalities in what area you are in. Like
yeah, exactly. Like depending on your GPS position.
Okay, got it.
Yeah. Gotcha.
Yeah.
All right. Well, I don't need any AI doing roadside checks. That's for sure.
Yeah, I mean, like if you go to Rhode Island, for example, you can't go fishing on a camel. Like you would need an AI to tell you that. that's a law. I swear to God. Then Rhode Island, you can't go fishing on a camel. It's illegal. That is one of their laws. So I don't know who made that law or when it but you definitely you'll get arrested going fishing on a camel.
Oh wow!
Fishing with a crocodile or something.
I have no idea when that law got enacted into a law, but it's there.
Huh. Yeah, they got some crazy laws that are still on the books, huh?
Yeah, funny ones too. But you just wonder what happened that back then that became a law of like what went on.
Yeah. Huh. Wow. All right, man. Who do you think's gonna win? Now we're getting to that Tyson fight now.
Yeah. Shit, I keep forgetting. You cannot put it live.
Boxing match.
Yeah, you can't put the sound on if you put it on.
No, I'm not gonna put sound on. I'm not.
We can or we cannot.
You cannot.
No, not. I'm not. I just wanted to see.
Yeah, they'll copyright us real quick and throw us right off the air.
No, I promise.
Yeah, I'm kind of man. I just want to see Tyson get back in the ring, and just when I want to see the Jake Paul's face when he gets hit once.
So it's the final match now.
I know it's going to be the final match. I don't know which match they're on right now.
Yeah.
So
no, it's the female female championship or something.
Interesting. Yeah.
Hopefully, did you know in the Olympics? Remember in the Olympics there was a girl that beat another girl very easily, and people suspected he was a transvestite, and the girl said no, he wasn't, but it turns out he was a transvestite. And
you're talking about the Olympics and that drug test thing?
Yeah, the boxing match, the female
Yeah.
category, the girl that lost against the other girl, but she was a transvestite actually.
Yeah, I don't want to get too far into it, but I heard that she was born with both. So
she was
born. Yeah. But obviously there's a dominant gene in there, so
okay.
Yeah,
I don't want to get in trouble from YouTube about that. I'll just leave that alone.
Yeah, because I have a billion questions on that. So if I let me keep my mouth shut on that one. But yeah.
No, but me, I just said the truth. I didn't put any judgment. I'm just reporting. They cannot block us for reporting something.
No, I understand. It goes so far off the edge so fast, Phil. You know what I mean?
Yeah.
That's a big rabbit hole to jump into.
You'll have a lot of advocacy groups on your, you don't want to go there.
Better off just leave it alone. Yeah. Yeah, whatever they decided. You know what I mean? I just hope they straighten it out by the next Olympics. So, yeah. Man, there's so many things you can't really talk about that are taboo on YouTube now. It's getting bad. I didn't really think it was that bad.
About what?
About anything. I mean, you start to go into one topic and you go a little off of it, and they're on it now, man. I don't know if it was
I can't wait till Elon Musk buy YouTube. You know,
is that really going through, or is that something?
No, but he should because he definitely should.
I heard he was going to buy McDonald's. So, that's a good one.
Yeah, I heard he's going to buy CNN, but it wasn't true.
Oh, darn it.
It was a satire. Well, one satire that was funny is Taylor Swift would boycott Red State or something like that. That one was funny. But it wasn't true.
Google's way too big for Musk is what he says. Yeah, Google owns YouTube, so yeah, that's a big ask for anybody to buy that. But CNN is losing half the ratings, so they might be for sale. They should just go back to
think about it. You know the mainstream media that they all agree to synchronize their news together. So, but that's actually what they did is illegal because it's like one company that monopolize the situation, like Microsoft and the antitrust law is exactly the same thing. It's just multiple little companies that are linked together with the same agenda. The same thing is monopoly and antitrust. So I don't know why nobody is suing them for that cause because that's exactly what it is.
Yeah,
they're on an agenda to normalize things in society that are honestly not normal, but they like shove it down people's throats so much, and it, you know, to the point where if you say, well, that's not normal, you're like an outcast, you know, because you're not agreeing with the things that like where did they come up with these concepts, or how is that okay, or how is that right, or you know, and it's like you question it, then you become like you know, an anti-democrat. Honestly, don't say that, but
Yeah.
yeah, it's just like, you know, the thing of the Olympics and other like, you know, issues in politics. I don't want to go deep into that because yeah, but it's not normal. You know, it's like one of the things I don't, you know, I'm not against a lot of these ideas, but I wouldn't choose them for my family or you know, my friends or my community that I would want around me. I mean,
Yeah.
that's the honest truth. Like you know, it's great that you believe whatever you believe, but don't bring it near me. Keep it to
But
yourself.
what they do to scare the population is they take one example and they they demonize him, and then they put all the blame on him, and then like for example there was Don Cherry. Don Cherry is a former coach of the Toronto Maple Leafs, and now he's just an announcer. And all he did, he said, you know, the little red flower to show respect to the vets. He said, oh, he was against those who didn't put the flower. He was against those who were not respecting the vets, and he lost his job. He was a he was like he was an announcer for 20 years, and he lost his job just because he said that. And now the rest of the population is all scared to death of addressing these issues because because of they use them as an example of what will happen to you if you do the same thing. You know, it's um, I don't think that's legal. That's terrorism. They terrorize us. You know what I mean?
Yes.
Yeah. Yes.
So that's exactly what it is. So um,
I just want to answer a question real quick. You said that Alexi lied about the ultrasonic piezoelectric technology, and Alexi was actually right. It doubles the amount of energy and frequency in the machine as soon as you hit the button. He's 100% right. So he didn't lie to you. He told you it was there, and it proves out in testing. So
Alexei of the Gravity Flyer.
Yeah. So trust me, I worked on that thing for months on that just one problem in order to prove out the theory. And it was he was right. Oh man. Yeah, they got a lot of stuff in there in the chat. I just kind of stay away from some of it. Yeah. But yeah, I just hope CNN goes back to just reporting the news because there's a lot going on around the world, and I'd kind of like to just know about it because I don't want to go in to watch a propaganda machine all day for just 10 seconds of news that I want to see. You know what I mean? I just want to know what's going on in the world, who's doing what, and that's it. I don't care about the rest.
It's like there's a news channel here in Montreal, French news channel, and they're linked to CNN, and they keep bashing Trump. Even before the election, while the election, and after the election, they keep bashing him. But why are they doing that? We cannot even vote here. You know, it's like, what the hell is wrong with them? You know, we can't vote for Trump or not, even if we like him or not. We cannot vote. So why are they doing that? Makes no sense.
And this is in Canada?
Yeah. They kind of tried to brainwash us against Trump, but we cannot vote anyway, so what's the point?
Yeah. So I don't know why they do that.
There's a lot of Canadian Americans too. You know, like there's a good percentage that hold both nationalities at the same time. So
Yeah, with dual citizenship, yeah.
Yeah.
Yeah. There's a Curtis here. Curtis, you miss all the action. The action is mostly at the beginning of the show. Now we're just talking politics.
Yeah. I just
talking politics without talking politics.
Yeah.
Yeah, without getting in trouble, right?
Yeah.
We're getting Mike's channel right on the edge of
Yeah.
the of the precipice.
Yeah. Sorry, I was just writing something in the chat. I just want to let Curtis know that Joe gave the first third of his presentation on his channel tonight. So go over and check that out. He did a really good job on it. Put a lot of good information on there. I know everybody's looking for what Gerald was doing. So he let the information out.
Very good. I'll have to watch it. I haven't yet had time today.
Yeah, he got
Very professional.
So you finally let that cat out of the bag.
Yeah, he did. And I'm very, very impressed with what he did.
I can't wait for part 2. And he said he's making a part 3. So we're getting a trilogy here.
Yeah.
Well, you have to do part 1 and 2. The third part has to be off of YouTube because of we're not allowed to talk about those subjects on YouTube, but it ties right in. Yeah, he's going to do it on Rumble. So if how do I say it? If you understood what it was, you'd see it perfectly. There's a whole design here in what it does. So it's truly one of the most interesting things ever, and it fits everything. And anyway, it's just one of those YouTube things. I don't even want to do it on Mike's channel because get in trouble. He got a warning for that, so we'll just kind of stay away from that. I'll just say it's definitely out there and it's definitely known, and definitely has proof to it as well. And I verified it in some of my experiments as well. So it's pretty neat.
Curtis is asking a question. If we had a chance to see his APEC talks,
it was on something else. I didn't get to see it on the regular APEC or
I saw his talks, but I didn't understand everything he was talking about, so I can't comment. I need to go back at the beginning, the roots of his talk to understand. Otherwise, if you miss the beginning, you just don't get what he's talking about.
I was watching on and off, so
Did you guys have to go on Discord to catch it?
No, I got an email invitation for the APEC. Like the one.
There you go.
Yeah, they do like 2 of them. They do one with it's an open mic, and then they do the more structured one. So the more structured one where they prepare for it in weeks, like what they're going to present, and then the open mic one is just the one that whatever comes up. Few people.
Yeah, but the open mic last week was the APEC anniversary.
Yes.
They did a whole stack of experiment, but we just heard about the Bluefield Brown effect, but the other ones, we don't know what happened.
They had I think maybe 12 people at the lab, and they were all showing off their experiments. Yeah, so.
Yeah, there was a whole stack of experiments, but there's no video yet, so I don't know. I don't know if they took a video or just pictures, but nothing was released yet.
Tim usually releases them slowly, he goes through and polish whatever, and then he releases.
I didn't get the invite to it, so I wasn't able to watch it. So when it comes out, I'll be able to pick it up and watch it.
Yeah.
So,
Yeah.
not part of the crew yet. Not part of their inner circle or whatever, or whoever they talk to. So,
I was there in New Jersey on their first anniversary. I went up to the lab.
Yeah, it was fun at the beginning. I really liked it. It was um, but now, like I said, we're being sidelined in favors of the PhDs and all these people. So the whole
Now I
point,
remember.
the whole point of APEC, I understood at the beginning was to anybody could talk about anything, but now it's there's kind of a mixture of politics. Anyway.
I remember something. Michael Boyd. You know Michael Boyd? I think he's a physicist, like an
Yeah.
something. He released a document from the Department of Defense. I downloaded it, and it's basically talking like a declassification document, basically talking about everything that we're experimenting or researching, and they're trying to like take credit that they already have research on these topics, and they've already have data and this and that, and and that's just. But I'll share it with you. I'll get it and I'll email it to you guys. Just for
It's just like Dr. Brandenburg, the guy who made the mercury spin, and he noticed a change in weight, an effective change in weight of the apparatus. Well, it's exactly what I've been working on for the last 3 years. He said, "Oh, I was working in a secret lab. I couldn't talk about it." Yeah, right. That's bullshit.
Man, you should have guys seen the Senate hearing. That was like some of it was almost too I kept on laughing. I couldn't hold my especially when this dude named Lua Elizondo started speaking. Man, this guy doesn't know nothing. I mean, instead of giving a speech or on what he knows, I think he thought he was the United States president and he was giving a speech on, what we should do. No, dude, what do you know? This is a hearing on things that, not what you are going to do in the future. Tell us what you know. I mean, go back and just watch his 5 minute, you would be on the ground laughing. It's like that.
That's funny.
Yeah.
Yeah, I don't trust that guy.
Man, any
What's
questions?
his name?
Lou Elizondo.
Okay.
Yeah, man, I don't think he's credible, and I don't think he should have
Well,
been.
he's known to be a disinformation candidate for the government. That was his job, literally, before all of this. Yeah.
The Speaker of the House kept on asking him very distinct questions, like, were you a part of anything that any retrieval program? And he was like, ma'am, I cannot disclose that because I signed a contract with the government. She's like, well, where's that? Where's the contract?
Yeah, where's the contract?
He was like, he doesn't have it. He signed it and that's that. He doesn't have a copy. It's like, well, if you don't have,
you can't reproduce it. Yeah.
If you don't have any evidence of what you copied or what you signed, how are you going to be held accountable if you say yes or no?
Exactly.
And then every little he wanted to make importance for himself, he would go, oh, I could only disclose that in a skiff. All right, come on.
Yeah, I would just, if somebody came start doing that, I would just tell Mr. Clown, get out. Just get out. We don't want nothing to do with you. We don't want your clown show. Get in your little car and leave. And
I think I should have said that, but they were giving this guy credibility on zero knowledge of anything.
Yeah, that's what I mean. Why bother?
I don't know.
He's not worth anything. Go. You don't have an answer. You want to just say the same talking point and leave. I have no room to listen to you. I don't have to waste my time. Just get out. You know what I mean? And then, hey, there's a little jail there. Throw him in it. You know what? Contempt of Congress, go sit in a little jail, little buddy.
The little jail in there.
Okay, I don't think he did anything wrong to be jailed, but maybe not to be lifted.
Well, he's obstructing the whole thing by sitting there with his thumb up as in Arkansas. He kind of deserves a little jail cell for a while.
These people are trying to, blow the whistle on some really serious stuff, and he's part of the opposite side, in my opinion.
Yeah, he's a clown.
Yeah, it makes me think of Dave Rossi. He keeps saying that he pretends he's from the hood in the Bronx. Yeah, right. The guy is from the neighborhood next to Mike in Toronto. He's not from New York at all.
Hey, he thinks he's a tough guy, huh? Hey.
I feel like, how are they believing this guy? Like, he doesn't present nothing that has any, factual basis. Like, nothing. Like,
Yeah.
I really, watched it really, really attentively just to try to draw out or take, anything away of value from what he said. I couldn't, nothing. The other three people might have said things of value or stated true facts or told the panel of where they can access that, those truthful information from what department or what agency but he had nothing, nothing that he could contribute, which was just kind of disturbing. Like, you've got the whole nation listening, he's one of four.
In my opinion, these congressional hearings are just a distraction. If you want to get some real information on the subject, go to the National Press Conference of 2001 that Dr. Stephen Greer held. There's a whole host of whistleblowers, engineers, people who claim to work on this stuff that gave their testimonies, and it's pretty incredible. It's like an hour and a half, 2 hours long. It's online. It's really a great conference. It happened in 2001. And there's some really good takeaways there. They go over the alien replication vehicle and everything. Mark McCandlish.
And this was a hearing in Congress?
No, it was a National Press Club news conference. So it was put together basically as a way to get this out into the public, because Congress didn't want to hear it, and literally until now they wouldn't even recognize the UFOs phenomenon. So
yeah, well, now they can't, because you have got a lot of these admirals and all of these generals are retired, the old ones, and now they just don't want to, they're not held by any more any rules.
Exactly, and imagine feeling the guilt. I can imagine feeling the guilt of having technology that can save the world, and you can't tell anybody about it. No, get out of here.
Yeah, well, that's the way they work.
That's not how I work, though, and that's what I'm, aiming for. More open source for this kind of thing, and I think we're doing a heck of a job on this show. These podcasts that we do, we disseminate a lot of good stuff.
Oh yeah.
Yeah. And I just added a link in the chat. Maybe you can copy and paste it on the public chat.
Oh yeah, I got you.
Yeah, it's about UFOs. It's pretty cool. It's very forgot. One sec.
Yeah,
it's a very recent video. It's about free energy. Yeah, that's what it's about.
I watched a little bit of that earlier. It was like I saw a tiny bit of a clip from it. It was really good. I wanted to go back and watch the full thing tonight.
Yeah, so they have free energy. They have the technology for free energy, faster than light travel. With that one, it's possible to go faster than light, but you need to create an artificial tunnel for that to lower the gravitational potential. So I know it's possible, but it's not like just a warp engine and you install and it's gonna work. It's a little bit more complicated than that. So that's why I'm surprised they know that it's gonna work How do they know it's faster than light? Anyways, they try it out, and I know it's not clear, but they pretend they have a way to teleport, like the Star Trek pods where you teleport. So they say that they have a technology like that. So
Gotcha.
you might want to check it out.
And that's all on that link that you put out there?
Yeah, can you copy and paste it in the...
Yeah, Ben put it in the chat, so I have it.
Yeah.
Right on. All right, guys, we're at 2 hours. So we're going to call it a night. We're probably going to watch that Tyson fight. Hopefully it shows up soon and we can really see what really happens there. I hope you came in ready to take him down. So I'm excited to see it.
Yeah, we should warn Jake Paul not to hit Tyson too hard. Do not poke the bear.
I hope he pokes the bear right away. Walks right into the trap. Oh, it's gonna be nice.
I don't think it started yet, right? It hasn't
No,
started.
not yet.
Yeah.
They probably got 1 or 2 more bouts before they get there. So. All right, everybody. It's been a great show. I want to thank everybody for showing up tonight. Thank you guys in the chat. I really appreciate everything. Have a great night and enjoy the fight.
Thank you.
Thanks, guys. Nathan, Phil, Lulu, chat. You've been great. Cheers.
Thank you, Phil. Bye.